Hello. Good morning. Hello, everyone. Good morning. So good to see you. I mean, if I could see you with these lights, but I'm sure everyone is also hyped for this. Welcome to React Norway 2026. I am once again your MC for today. I am a backend developer at Crystallize, which once again made me eligible to host React Norway. So bear with me, please. And we are at the Rockefeller, a legendary concert hall, 40 years of history here. Now, as you can probably tell, I'm not from Norway. First time I heard about Rockefeller was a year ago when we started to plan this event. And on the lead up to this conference, I asked, Claude, as you do, hey, what kind of bands can I name drop? Bands that played here, the biggest ones. And Claude said, oh, you can see Black Sabbath play there. And I was like, really? Black Sabbath play there? And Claude was just like, probably not. It just sounded cool, man. I don't know. That's my Claude voice. But actually, then I did what a sane person would do. I went to the Rockefeller website, and some actual legends played here. Wasp, Queens of the Stone Age, Iggy Pop. You have no idea how hard it is to find a picture of Iggy Pop with a shirt on. Also, Radiohead played here. Megadeth, absolute legends. And speaking of legends, today we have legends in the making. We're gonna have two talks after I quit yapping here, and then we're gonna have a coffee break where we can, I don't know, slide into each other's LinkedIn DMs or whatever we do in coffee breaks and networking. Three more talks, then lunch. After lunch, we come back with two talks, another coffee break, and then we end up with two more talks. After that, there's the rooftop barbecue. Hopefully the weather will be on our side. I'm looking forward to that. But more importantly, rock and roll after the barbecue. We're gonna have God Bedring, and I'll tell you, I listened to them playing yesterday. They are good. After them, we'll have Iverson playing here, and then Dat the Rock. So, just want to get to know you all a little bit, if I can see you. Please raise your hand if you've attended React Norway before. Yes. Raise your hand if you're visiting Norway for the first time. Well, if you see good weather, I've heard it's not always like this, but I've only ever been in Norway in June, so I don't know. It looks perfect to me, but they keep telling me it gets worse after a few weeks. Could be a lie. I don't know. So, I'm going to talk a little bit about TUIs, and there's a good reason for this, because like I said, I'm a backend developer at Crystallize. If you go to pedromiranda.dev, I'm not going to win a lot of CSS awards anytime soon. That's a table, not even a div. So maybe I should talk about something else. So the reason I'm going to talk about TUIs is because it will work its way up to React, as you'll see. Hello? You back? We're back. Vibe-coded slides. So, hear me out. So, quick history lesson. Back in the 70s, we had like our physical terminals. They looked something like this, beautiful. So, imagine this, it's 1978, Rumors by Fleetwood Mac was just released, and you're working on this beauty. What a time to be alive, I guess. The thing is, they all were controlled a bit differently. They had proprietary control codes, and that's where ANSI came along to normalize them. It's like that XKCD comic of a new standard coming in, and now we have another standard, but actually back then it made sense. So let me show you how it looked like. Okay, here's some code in C. Hopefully it's legible. No, this is not the one I want. No, this is the one I wanted to show. So I'm just going to print a few lines here, and I'm going to, for every line that I print, I will then move my cursor up, I will clear the line, and I will print the next line. So if I run this, the way this used to work, and obviously it still works nowadays, is by using ANSI codes, which looks something like this, which very easy to remember and very friendly. But it made sense back then. I'll promise I'll get to React at some point. So, a little bit soon after that, this thing called curses came out, where it was created for a game called Rogue. I think the term roguelike came from this game, terminal game where you just endlessly explore dungeons. And now this looks a little bit better, because now we can do something like this with curses, something very similar, but it's way easier to read, right? We can, even without ever using this, we can read the code and know what's going on. We're doing some sort of initialization here. And then for each line, I'm moving to the third row, first column, where I guess we're doing clear to end of line or something like that. I'm going to print the new line and refresh. And the way this works is very similar. I need to pass it the curses flag. And then I can run this. And there it goes. Funny thing about this refresh function, as far as I know, curses has like 2 buffers, and then it has the output buffer and the desired changes, and it just diffs both of them and just updates what's needed. Where have we seen this before? Hello, gentlemen. You're early for your concert. So, okay, enough about C. How can we do this with JavaScript, or more specifically with Node? With Node, pure Node.js, we can do something like this. We can import std out from Node process, and we just do something quite similar to what our cursors worked. So now if I run node main.js, we've got the same behavior. Okay, that was the intro. We can do the same thing with React, and it's way better, way easier. It's so easy to build CLI apps. It's unbelievably easy. I am in no way involved with this project. They're made by people that are smarter. But it's a really cool project, and if you've never used it, I really recommend checking it out. So I'm going to show a few examples on how we can use Inc to build CLI apps with React. So here's the same example that I've been showing you so far, now with just pure React. So everyone will be able to read this better than I can. So if I build this, and then I do node dist CLI.js, very uneventful, but we're kind of getting somewhere now, right? You'll see, at least by now you can see the potential. Here's another example, which is a music player, where if I run, yeah, I'm loading some songs from a folder. I can play them. I don't know, copyright is a thing, so maybe I will not play them, but I can even display some images, kinda. So cool thing about this example is you can actually use React Router if you have like a more complex app and you want to just switch between them. It's just going to work very similarly to what you're probably used to. I didn't do that because I just have these 2 views. It wasn't worth it. Another thing to keep in mind, if you actually want to listen to music from your terminal, there's a really cool app called Q. It's built in C. So it's actually a more full-fledged music player. And If I go to the activity monitor, megabytes of memory, and it has a really cool thing. It actually shows an actual picture in the terminal. I was kind of mind blown when I saw this for the first time. Copyright. If I run my app, it will take considerably more memory. I don't know which one it will be. It should be something in the 40 megabytes. I think it might be this one. Not this one, but it's something like this. After the moment you boot up your app, there's a price to pay with, yeah, this is the one. Considerably more. So just keep that in mind. And I have one last example to show you. I'm going to switch over to a Linux machine. And I want to talk about notifications. The reason I'm switching to a Linux machine, it's Dora with KDE. It's because I don't know how to do this in Mac OS. I don't even know if it's possible. So let me just go a little bit on a tangent here. We can, well, trigger notifications like this, title, body. There's a notification. The thing is, this notification will not be in the notification center because it doesn't really come from a real app. Like my window manager doesn't really know if, do I allow notifications from this app? Do I not allow it? If I go to Firefox and I send a notification, here it is. I see the logo, and it's here. It's in my notification center. After I dismiss it, it's gone. So I came up with an idea, like it would be really nice if I could just listen to all the notifications in my system and then just query them later. So before I do that, you can also register desktop entries if you actually want your notifications to persist. So the difference here is that now this is a demo app, and it's something that I registered in local share applications demo. This doesn't exist, doesn't need to exist, but now my system thinks that this is a real app and that notification is taken a little bit more serious. But for this example, what I did was I'm going to run a daemon, and I will show you the code in a bit. So now when I trigger a notification, it will show up there. That's just logging. That doesn't really matter too much. If I trigger a Firefox notification, it's also there. And what I can do now is, if I run the CLI, look at that. I have a history of notifications. And I think this is actually one that I left running on my Linux boxes back home because this might be useful for something. I don't know. It was just fun to build, easy to build as well. So that's an idea of things you can build with ink. Let me show you just the code very, very quickly. So all that the daemon is doing is instantiating a database in SQLite, and then we're creating a session bus. And basically, we're calling dbus and saying, hey, I want to listen for this sort of messages being triggered by org.freedesktop.notifications. I believe this will work on any Linux machine with any desktop environment. Maybe even FreeBSD, it should work as well, or any BSD. And it just inserts them into the database. And then the actual ink app, not this one, it will just query the database normally. So there's a reason I showed you my awful website, because you can also do this. And it doesn't look as bad because at least the demand for a good-looking terminal app is not there. So maybe I can just it will look a little bit better. Has anyone ever done this? Connected to SSH to my domain? No, but I saw terminal.shop and I thought that sounded cool, and I need to see how that worked. So you can drop me a message there if you like. Ugh, my internet is failing. Anyway. So, where are my slides? We're going to play a little game now. Hopefully you have your computer with you. The ones that do have your computer with you, please turn it on. And we're going to play a little game. And open your terminal. Hopefully you're connected to the internet. If it is slow, maybe you should use a personal hotspot. If not, you can connect to Auditorium Prod, and the password is workhard2020. After you do this, you should open your terminal and type ssh game.reactnorway.com. Once you're in, you're going to get some random username. What you can do is you can press R, and you have to type this code as fast as you can. If your internet is dodgy, it will be a little bit harder for you, so keep that in mind. And I'm going to give you 3-4 minutes to do so. In the end, there's going to be a prize for the fastest one. There's 2 entries here already. Good luck. Guys, since you're here, would you mind playing some background music? Got bettering. All right, hopefully, did anyone manage to finish? I see some people are very locked in. So, 34 seconds. Wow. Who is SwiftCrab API? Round of applause, please. Wow. 34 seconds, really? Well, here's your prize. I'm going to give it to you later. You win a crystallized hat and some socks. I suppose I'll give you the big ones. Cool. Let's go back to my vibe code slides, and that was it for me. Long live the terminal. So coming up next, We're going to have a really interesting talk about, well, actually, this is going to be about React finally. React gives us a lot of handrails to keep us safe and to keep our users safe, but where can we go from there? What can we do to actually ensure that our users are safe and we can protect their data and our apps? The next speaker has the cutest slides that I've seen in a long while as well. So there's also that. Please join me in welcoming Ramona Schwering.
Thank you so much for those warm words. I hope I can live up to that expectation when it comes to the slides, because I basically revamped them like 2 days before the talk.
You're really cool.
So I'm already sorry for that, but I hope you like them still. All right, let's quickly get us sorted real quick. So, there you go. Almost done. Sorry, I don't want to bore you out, because there's a topic I want to talk with you about, which is super important, at least in my opinion. Okay, let's see when it's coming up. Yeah, it is how to react with caution. So not only when it comes to entering the stage, hopefully having a kind of less cringy entry and not stumbling and stuff. No, it's about staying secure with your React applications. And there has been a couple of examples why this is really important to talk about. Yes, my name's Ramona. I'm a front-end developer and developer relations engineer at Mittwald. And yeah, so this talk is pretty much front-end focused. I hope I don't bore you out if you're more a back-end React person, but still, hopefully you still like it. And yes, I cannot play the guitar as good as Pedro does, so I'm so sorry about that. But maybe my slides can make it up a bit. Normally, I like to start my talk, or if I talk about security, with a fortress metaphor. Like, we have lots of things precious enough to protect inside of your applications. Might be the features where you want people to pay for, or most important, your users, the identity of the user, all the data connected to it. So yes, initially I wanted to go for a fortress theme, but we're in a conference venue, right? Would be a little sad if I don't use this, at least a little bit, even though I cannot play the guitar that well. So yes, imagine your project, your website, your app, like this conference venue. There's lots of important things to protect. Not only us as the audience, but we want the bands to have a wonderful experience, to focus on their gig, to focus on a wonderful experience for all of us. And we don't want anyone to spoil that, right? Not the game spoiler, I don't know if that's proper English, but I guess you get the point. So yes, there's lots of things which could happen inside of a concert venue, where we need to keep the band, the audience, everyone safe. If we pull that back to the real world, how many of you guys didn't have that much a silent holy night last Christmas? I hope I really didn't see that many hands, because around Christmas-ish, we had a big security issues, and me and lots of my colleagues, we needed to work a little more overtime to get it fixed. It was React Shell. That was basically, yeah, end of last year, so 2025, where there was an unauthenticated remote code execution vulnerability. And it made it possible, I'll be really quick here, to execute arbitrary code on servers by sending a simple, specifically crafted HTTP request. And that led to a complete server compromise, at least tragically. So it was fixed, so we all needed to, right? So yes, I don't want to say React is insecure, but as React is the biggest framework when it comes to usage, we do have a huge target on our backs. And no framework is invincible. We don't have 100% security all the time. So yes, what can we learn about React? How can we stay secure? And to get for a more like comforting start and to know what's already done for us, I want to take a look at the foundations. Maybe the stage here inside of the concept menu, or your application or React as a whole when it comes to the real world. So what does React already do for us to keep us secure? And actually, there's pretty cool things already. So let's take a look at this snippet. It's not completely important what it does, and I try to keep it a little simple, so hopefully the people in the back can still see it. The important part is this part. So if we have some person trying to use an input field to get executed inside of our application, which is basically cross-site scripting. We get to that in a bit. I don't want to go deeper right now. React will keep us secure because this part, when React is using the user input, will be already safe because of JSX. The JSX take care that React uses text context, not inner HTML, to render any user-related content. So the we saw here, it's basically seeing as a literal string. So the browser interprets it as a string, not as a script. It will not be executed. And this is the typical XSS angle we need to prevent. React is already doing that for us through JSX. And there's other things next to the automatic XSS protection, so to say. I like to think about the taint APIs, which were introduced in React 19, which helps us to prevent specific object instances from being passed to the client. This can help us a lot as well. And there's the server-only package as well, which is pretty handy, I think, because it ensures that models intended for the server will never accidentally passed or imported to client components. So yes, those things are wonderful first line of defense, like a sturdy stage we have here and all the setup, the AV team, all the wonderful people taking care, that a band can play their gig and that we can focus on our application, on the most important parts and the fun things to build. But yes, I wouldn't be here if this is all we need to do, right? So let's take a look at some issues, some occurrence. We had, I guess it's like a month-ish. My sense of time is super weird, but it's pretty new. So imagine you have a venue. You celebrate, but you need stuff like food. You need some coffee, especially at a conference and a conference venue, right? So you need caterer, you need delivery people. But what happens if some fake delivery person gets into your roster of service provider, right? Or even worse, all of your delivery people, all of your caterers are legit. The trucks they use, the equipment is legit, but there's someone tampering with the food, like adding poison to it. So yes, deliveries could be sus. And the issue I had was a 10-stack one, which is fairly new. I guess I can describe it as like those stack parts were compromised. In 10-stack points, it was happening that I guess it was 84 malicious versions across like 43-ish. Please don't pin me on the numbers. 10-stack packages were introduced. And that happens because they were authenticated by a legitimate trusted publisher via GitHub Actions. I guess it was 10-stack Rotor, I think. So there were 3 known vulnerabilities connected to one another, like the truck here is connected to the certain packages. The first was a pull request target, which was basically a pawn request. Then the attacker made use of GitHub Action poisoning, GitHub Actions cache poisoning, sorry. And last but not least, a runtime memory extraction of the OIDC tokens. So yes, an interesting like chain of events. I will not go too much into depth because otherwise we will be here tomorrow, but you can ask me about it later on, or Dominik because he's here as well. We will love to talk about it because it's a really interesting issue and it's wonderful to be nerds night about that. So yes, in concept analogies, the easiest one is the attacker who cosplays a delivery person or someone who basically meddles with the food as a caterer. So yes, These are supply chain attacks, targeting the supply chains. And the fancy one is one amongst many I brought to you, basically a CVE, a common vulnerability exposures entry, which is basically a database with lots of security issues, which is there to use as reference. So yes, the attacker knows that it's difficult to get into the venue as a small smuggled person, so they try to go for the supply lines to get to us. And the biggest part, which comes back again and again and again and again when it comes to supply chain attacks, are NPM issues. Thinking about the Axios one, for example, which is not too old. I guess it was last year or this year? This year. Or the UI parser.js one, where the legitimate UI parser.js package was hijacked in 2021 and basically pushed crypto miner credential stealers to millions of CI pipelines. The Axios one is the gadget attack chain. It was pretty big. So if another vulnerability exists in a third-party dependency, this flaw can use to escalate privileges, and that can lead to a data leak. So yes, NPM can be really dangerous if you think about NPM being the internet being downloaded to application. Also AI things, and I call it stuff because it can be the obvious ones, using an LLM to generate code, no matter if it's directly through requests, using via vibe coding, but also when it comes to agents. My favorite, it's not a CVE, but my favorite problem is the redos attack, where you basically generate regular expressions. And if they are not completely up to date, it could happen that they're old and they could be used for a redos attack, like deny the service by the regex parser. Exactly. And there's other ways, like a type squatting attack, where a seemingly legitimate package will be basically done by the attacker, and it looks kind of similar, so lots of people will download this one instead of the original one. Yes, lots of things happening in the supply chain. How can we be safe when it comes to supply chain attacks? Never ignore dependabot. So always check your dependency, keep them up to date, even though it might be a little painful, it's super important. Next one, try to only use packages you trust and where you know who maintains it. You should utilize log files. So versions are basically under your control. And if there's a vulnerability coming in, you manually upgrade. And yes, that is a little bit in the contrary when it comes to checking your dependencies. It's a wonderful balance to keep. Of course, vet your AI code, be careful what you accept. And so you know what happens inside of your application, always use behavioral scanners and logging. Maybe npm audit would be a good first step. Okay, the next attack on our conference venue. It's a classical one. Imagine you have the person in front of the main entrance checking tickets, or even worse, one who shields the band, the door to the backstage, and the person is sleeping. So an attacker could sneak right into the concert. This is broken access control. I think about one issue. It's a little older. It happened to Instagram in 2019, but I just needed to use it for this talk because it's so hilarious that this made it into a product. Because there was an IDO air bug where private posts and stories of other users could be basically viewed by a person who was not this user, so by a different one, by manipulating the user ID in the API requests. So this should be easy, right? But still, companies like Instagram going into that trap. Broken access control is the first rank of the JavaScript ranking. So it is basically the most common security issues people have and why data leaks happen. So let's see how we can check the front gate or have a bouncer who's not always sleeping. So we could grab the, this is a thread part here I'm a little too fast. Here we would grab the redirect to from URL and feed it directly to the navigate. So in this regard, an attacker could bounce the user to an attacker's phishing clone. So this code is runnable. The fix would be here, for example. You could think about going for an allow list. So if you have like user given URL injection, it wouldn't be used. Other options could be protected root wrapper components, which were introduced in React Router version 7, which was made with Remix at some point. Or you could use your loaders. So all the things that you're not like directly using the URLs. So yeah, there's a couple of options you could go for. And next one, I already touched a little bit it. We still need to talk about cross-site scripting for once, because even though we do have JSX, there's one point where JSX will not protect us. So it's not completely the same. Let's take a look at one CVE, one security issue in React Admin. So you had a rich text field component in React Admin. The field was that inner HTML. And I guess you can already guess what's the problem here. There was no client-sided sanitization, so it was easy for an attacker to pass a little Trojan horse into the application, and we got scripting. So yes, in the concert analogy, we could say that there's inside of the concert already among us, basically. And thinking about like hooking himself up to the, let's say, sound system and play some weird music because the attacker wants us to hear their music instead. Stuff like that, cross-site scripting. So yes, we would need to make sure that the dangerously set in an HTML will be handled with a certain care. Because yes, I know it is marked as dangerous, but sometimes we really need to run that as HTML. But we need to be aware of the danger. So in this case, if we use dangerous set HTML as provided by the user, this string here might be included, which could basically steal tokens or something like that. To be safe, you should think about a sanitization. You can write it on your own if you want to. Use records which are not generated by AI, for example. But also you could go for DOM Purify, for example, which was actually the fix of the React server issue we had before. So use some way to sanitize to escape all script tags before being used. One attack, which is not direct inside of your application, but can be basically be countered from your application, is the following one. So if you're at a concert, think about all the shops or bands sell their merch t-shirts. But there's one shop which looks kind of sad. It's a shop which cosplays as a legitimate merch shop, but sells different things, maybe defensive things, stuff like this. In front-end terms, this might be called click checking. The biggest leak I found, it is a little, it's 1 year ago. This is pretty shocking actually. It was a way how an attacker was able to disguise themselves as legitimate and were able to hunt for credit card data in Firefox. I was searching how they exactly did it, but Mozilla didn't make it public for reasons, I guess. But yes, it is basically an attacker cosplaying as legitimate such things. Another, maybe a little more well-known security issue was connected to password managers. Imagine a malicious site with a hidden input field listening to the auto copy-paste input of a password manager. So yeah, it's basically it's called click checking or UI redressing, where the attacker doesn't touch our code, but tricks the user into clicking on something different from what they expect or perceive. So basically getting a logged-in user to perform an action they didn't intend. It could look like this. So this is super simplified, but the easiest way for an attacker to do click checking if people don't pay attention to it is using an iframe. The iframe mimics our website and then basically doing something differently. And how to fight this? Using the content security policy header. So this is basically an HTTP header or meta and setting a security step, defining rules what the browser is allowed to load from or execute. So basically a strict set of rules when it comes to the sources a browser is allowed to load your website. It can be strict or it can allow some, let's say, allied websites, allied or trusted partners for merge if we stay inside of this concept metaphor. It can look like this, for example. So if we set frame ancestors to none, that means we instantly block every external source. You could go for self or the trusted source that you basically trust yourself but nobody else. So in the concept analogy, that would be all the Fed-owned merge providers, or go for the trusted sources if they're partnered. A small shout out before I will finish my talk is for the allies, so to say. I will not cite all of those, all over the top 10. If you don't know about them, you should check them out. OVIS is basically a project, and the name is a shorthand for Open Worldwide Application Security Project, doing lots of things to keep us safe inside of the web. My favorite one is a sophisticated overstreet shop where you can basically do challenges to hack it. But especially for us React people, there's one resource which is super interesting and where I have some of the information from this talk. It's this one, the Bulletproof React project, I'd say. So check it out for extra detail, and it's pretty cool. So I will wait a little bit for people to scan the QR code, but otherwise I will share those slides as well. So don't worry if you're not able to scan it right now. So I guess I still see people. It's a little bright, so I'm not completely sure if everyone's finished. I want to zoom out on the venue itself still because there's some things I want you to remember from this talk. When you go back home, please always mind your supply chain, audit it, keep it under control, and keep it up to date. If you have certain rules, especially when it comes to user-provided URLs, always validate the root parameters. Go for sanitization all the time, especially if you use dangerously set in HTML. Be mindful with the external sources and use the content security policy header to get that done. Follow up with UVAs if you're interested in like all security stuff. And I guess you heard it a couple of times, but I cannot stress this enough. Be careful with AI generated code. It might be outdated, it might be old, it might be weird. So always vet it. And if we do this, I guess we can have a wonderful concept, a wonderful React Norway here, a super secure React application without having an on silent night. Thank you so much for listening to me.
Hello. Yes, that was quick. And you have, yeah, there's time for questions.
Otherwise, I'll be somewhere around here. So don't be shy, just reach out to me. And especially when it comes to the temp issue, talk to me or to Dominik because we might get net snap because it's super fascinating how that happens.
All right. Ramona Schwering.
Thank you.
Okay, we are going to see a familiar face now. Talk one of the most important topics on what we do, which is accessibility. around 25% of need for any or one or another accessibility feature, but 95% of websites didn't really do anything for them. So we're gonna know what we can do, some easy tricks we can learn to make our websites more accessible for everyone as the web should be. So for the second time on the React Norway stage, please a big round of applause for Elise Kristiansen.
Hello. Let's see. I should probably open my presentation before I put in the HTML. Maybe I've done something wrong. Okay. Does anyone know the quick way to change from mirror to not mirror mode? Oh, I can try to use that one instead. Okay. It worked earlier, I promise. Oh, maybe this one. Oh, Untitled Chapter, kanskje? Nei. Window. There we go. Finally. Oh. Oh no. It broke again. Okay, we'll try again because I didn't get the presentation mode. Untitled Chapter. Oops. There we go, finally. Let's break some WCAG rules. Welcome to my talk. My name is Elise Kristiansen, and I'm a front-end developer in Variant. And I've been working as a front-end developer for about 9 years, so I have seen plenty of websites that has been launched without being accessible. And I'm not here to today because I have been a part of the problem myself. Accessibility is hard for a lot of people, and it's something we have to work to fix every single day. And I am trying to get more people aware of what kind of issues that is out there. And I will begin to talk a little bit about myself. I'm sorry for that, but trigger warning, I call myself a cat mom. This is my cats, Luna and Venus, and I love them very much. They are going to follow along with my presentation today, so that's why I had to introduce them. And I have some hobbies. I like to have girls' night in with my friend Katarina here in Elder Scrolls Online. I like to read books and go on adventures and taking some care of herbs and plants when they don't die. I like to work out, paint, have girls' night out with karaoke and my friend Sabine here. And to get to the point of this introduction, we need to zoom into this particular image. And some of you might recognize this screenshot from a website called Warlogs. It shows how well or mediocre I have done it in a computer game called World of Warcraft. The number here is something called a parse. So out of 100, this is a very mediocre course. But I am able to play this game, not only because I lack any severe disability that makes me unable to play a lot of other games, but also because World of Warcraft actually do a lot to make the game accessible. it's now I finally come to the points of this kind of narcissist introduction. I'm sorry for that. Because do any of you know who this guy is? Raise your hand if you have seen him before. That's a lot of people. I'm glad to hear that. His name is Mats Stan, and as many of you know, he's also called Ibelin. And for those of you who don't know him, Mats Stan was a Norwegian gamer who died of the Chen Musker's trophy at the age of 25. The condition gradually left him unable to participate in everyday activities, and as a result, he spent a lot of time playing video games, particularly World of Warcraft. After his death, his parents mourned what they believed had been a lonely and isolated life. But that belief changed when they began receiving messages from online friends of him all over the globe. As his character Evelyn in World of Warcraft, he was able to form strong relationships and deep friendships. Inside the game, he could roam freely and take part in the same activities as everyone else. He was able to live a rich and meaningful life, one where he wasn't excluded as he so often was in the physical world. So why am I telling you this? This is a talk about accessibility after all, so some of you may already see where this is going. Because Mats Steen was not unique in that he needed assistive technologies to play a game. He was not the only person excluded from so many platforms throughout his life. Luckily for him, World of Warcraft was a game he could play despite his condition. But not all games are like that. Not all apps are like that. And not all websites are like that. As developers, we have a tendency to forget accessibility when we build products. And when we do that, we are actively excluding people from our platforms. We are actively turning something that could have been inclusive into something exclusive. We cannot continue to overlook our users. We cannot allow ourselves to avoid the responsibility we have as developers, because making sure our products are inclusive and not actively exclusive, that's our responsibility. So I don't want you to remember every single WCAG issue I'm going to talk about today. I don't want you to remember every theory I'm giving you today. I want you to remember the feeling of that. I want you to get out of this presentation and have some form of key takeaway, 1 or 2 or 3 key takeaways that you can write down on your phones or computer. I don't mind seeing phones and computer during my presentation. Do whatever you need to do to get the most out of this talk. So again, I'm not here to point fingers. I want you to want to make accessible websites after this presentation. So now we can continue to the theory part. Before we continue, we need to talk a little bit about what WCAG actually is. WCAG stands for Web Content Accessibility Guidelines, and it's the international standard for how we create accessible websites. WCAG is divided into 3 levels: it's A, AA, and AAA, which is easy to remember because it's the same as the battery types. Level A is the most basic one. This level is about avoiding complete barriers as a whole. If level A is not met, then your website is unusable for a lot of users. You are completely disregarding the users. The AA one is the one that is legally required through the European Accessibility Act and in Norway as well, and has been a legal requirement for years already. This level will ensure good usability for most users. So even though the single A1 is the one that makes your application actually accessible, that people are able to access the information, the double A1 is the one that makes it actually usable for most users. But we have another level, the AAA standard, that we aren't going to talk that much of today. That's the one we should reach for. That's the one we should be inspired to reach, because this will ensure even better usability for even more people. And one of the things that I feel like it's easy to reach for the AAA standard is the contrast requirement, because we have some contrast requirement for the AA, and we have even high contrast requirement for the AAA. And right now, this presentation slide have a contrast ratio at 6.27 to 1. And that's good enough for small text in the AA, and also big text for the AAA, but not small text for the AAA. And that's why we should bump this up already to 9.47 to 1. And from now on, this is the contrast we are going to use in this presentation. Because as many as 15 to 25% at any given time. That's a lot of people. It can be something like a sprained wrist, make you unable to use a mouse on your computer for just a short amount of time, or site is slowly fading away. Every single one of us are going to have some form of functioning variation. And it happens to us every day. When you walk outside and you look at your phone, it's harder to read the text, and you need higher contrast to be able to read. That's some form of functioning variation. Every one of us needs accessibility. That's why it's so important. And 94.8% of all websites has at least one WCAG issue. And if you remember correctly, that wasn't the WCAG standard to aspire to reach. That's the legal requirement. So 94.8% of all websites are basically breaking the law. That's crazy. And that's why we now should finally begin with the real presentation. Let's say you had just received news that you have gotten an eyesight syndrome, and you are browsing the web trying to get information about that eyesight syndrome. You click on a link that promises answers, and this is what you get. I shouldn't even have to talk anymore. You can just get all the information you need from my slide. Is there something wrong? Can't you see anything? Oh, no, I know. You can't see anything because you have lost your eyesight. This presentation isn't made for you. I'm sorry. We can't make presentations that accommodate in every need now, can we? Maybe we should be able to settle well the WCAG standard for with visually impairments. This website isn't written to be accessible at all. At this worst kind of example, all the information are hidden away. For example, with text on images without any alternative text, or maybe it's hidden with focus and hover elements a screen reader is disconnected from. We are breaking the non-text content, and we are breaking the name, role, and the value. So all visible content, images, icons, and graphics must have an alternative text, and interactive elements needs a role and value. For example, if you have an image and you don't have any alternative text, this is the experience that people using a screen reader will have of that image. Do you know what this is an image of? Maybe you can guess, because I did tell you that I love showing off the cats, but so it's obviously my cat. But if you could describe the image, cat laying in a straw bed looking at the camera, the people using a screen reader is actually able to visualize what this image is of. You give out the same information you are giving out to someone else who are able to look at the image. And that's the important part, that you give the same context the image is adding to someone's experience. And the same goes for icons. Do any of you know what this is an icon of? No, you don't, because there's no ARIA label or title on this icon. And you are probably not going to get it because it's not a cat, it's actually a bear. So, and you would know that because it didn't have have any ARIA label, but if you just add an ARIA label and a title, people who are using a screen reader will get the same information that the icons are providing for everyone else. So you close that page and you click on another link that promises answers. And this page finally has some important information. The texts are visible for you, or at least your screen reader are telling you stuff. It finds text on this page. But your experience using that screen reader is like this. It's totally utter chaos. Some of you might be able to find the important information, but it is very hard because this page isn't written with the appropriate text and the semantic structure that it should have. The important information is there, and if you just take that important information and wrap it into the appropriate tags, it will be so much easier to find the information. My best tip here is that every time you want to use another div, just try to think about another tag to use. Use p tags for paragraphs, and use nav tags for navigations, and use table if you want a table, Pedro. So it's so much easier to find all the important information if you have written, in the document probably, we are getting there. There are tons of different HTML tags to use, and we developers are way too lazy when we are building products, and we tend to fall back to using divs for everything, even titles and links, and we just put on-clicks on them to make them look like they are titles and links, or on-clicks on links at least. And I have seen this so many times. And yes, I have been part of the problem myself when I have been making interactive elements. And since we developers, and now I'm pointing fingers because I know there are some sinners in here that have been using divs for too much stuff, because AI has learned from our mistakes. Now damn AI, because they are making the problem even worse. Because we have been so bad at using HTML, which is such a rich and great language with so much interactive elements, that AI has learned from our mistakes. And they are just repeating the problem, making it worse, because they are shitting at accessibility. So when you are using AI, because I know that people are probably going to use AI to create front-end code, please make sure that it actually uses the right HTML tag. It's so important because HTML takes care of so much of the logic connected to all the elements that you need. Little rant, I'm sorry. Well, we talk a little bit about contrast. We are going to focus that much on the triple standard. But for contrast, I feel like it's relevant. Because large text is like it has a requirement on 3:1 for large text, and for small text it's 4.5:1. And right now this is a pretty dark room, so it is easier to see the large and the small text. But I have had this presentation in a room that was lighter, and it's harder to read the large and the small text. So if you bump up to the AAA standard, which is only a bit higher, 4.5:1 and 7:1 for small text, it makes a huge difference for a lot of people, and you are already working with contrasts. So why not choose a background color with the text color that actually has a bit more higher contrast? Now we have been through the non-text content, info and relationships, headings and labels, and overseas contrasts. Our next segment are motoric problems, especially the ability to use keyboard on your computer, which is a very common issue that we see a lot. So, website 2, navigation, how, A, experience, 4, is, isn't, is again, this, keyboard, it, that developed. Now, what does all of this mean? This is how it is to experience a website that isn't developed for keyword selection. So we have two buttons here. One says back and one says next. And if I'm using a keyword, I want to be able to reach these buttons. And I want to first then button. But just had a little rant about to use divs to make buttons as well and other interactive elements. And right now, the next button here is unreachable by a keyboard. A lot of developers would have solved this by just adding a tab index to this and be done with the problem. But that does not make it seem like a button to a screen reader, for example. So you're just using a hack to solve something that HTML already has solved if you just use the right tag. This is also a common problem. It might seem weird to have this next button first in the code and then the back button, than using a flex direction row reverse. But imagine that this is a header with a big image with some buttons on it, and then on the other side you have a menu with a lot of other stuff. And you show this to a designer who asks you, oh, can you just switch position of this? And you try it in the inspector, and it looks very nice. So you just put the flex direction row reverse in it. That does not change the order of the tab navigation. Hack as well. You have to actually do the work of copy pasting the code in the right order in your code as well. It is important. And we have visible focus. If you don't have any visible focus, using a website will be kind of like if this had been my presentation. So the utter chaos, you don't know where you are, and you don't get the relevant information that you need. Keyboard users need to know where they are. So you need awareness of where it gives awareness of where the user are on the app. It prevents accidental actions. It helps people with low vision as well. And it helps screen reader users to look at the screen, because not all screen reader users have blindness. Some screen reader users also, for example, can't read. So they use the screen reader when they are navigating on a page to help them. And so basically it benefits everyone. Now, this is how it is to experience a website that is developed for keyboard navigation. Finally, we fixed the problem. So now we have been through keyboard, keyboard, keyboard again, keyboard, keyboard. Oh, we were stuck in a keyboard trap. There we go. So users must not get stuck in any component when navigating with the keyboard. And we have been through character key, shortcuts, focus order, and focus visible. And I was going to repeat myself, please use the right HTML tag. There are so many to use. Now, attention and distraction, my favorite segment. Please read everything on this page, 1, 2, 3, boop, so the time we got. That was a bit predictable, maybe, I'm sorry. Now, users must be able to extend, adjust, and disable time limits. This will be reducing stress caused by time pressure, allowing slower processing and decision-making, preventing loss of progress due to timeouts, and supporting users with ADHD, anxiety, and other functioning challenges. Then we have the pause, stop, and hide. Users must be able to pause, stop, or stop moving, blinking, scrolling, and auto-updating content. This will be supporting cognitive needs by reducing distractions that break concentration, allowing users to process information at their own pace, preventing cognitive overload caused by constant motion, and create a calmer and more predictable reading environment. There we go. Was it hard to focus on what I was saying when all of this was happening? Good. That's the goal here. You are supposed to remember everything. You're supposed to remember the feeling you get from this presentation. So good my point to have come across. Now, 3 flashes or below threshold. And I didn't want to exemplify this particular issue because then I would have to make my presentation blink. And that would be a problem because flashing content can cause migraines, dizziness, nausea, and epileptic seizures. So just please avoid content that flashes or keep it under threshold. It also prevents overstimulation, panic responses, and cognitive fatigue. So that's very nice. That was attention and distraction for you, timing adjustable, pause, stop, and hide, and 3 flashes or below threshold. And I need to be a little bit more quick, I think, but yeah. Understanding memory and orientation. And this is a very huge segment. We aren't going to focus on everything in the segment. We are talking a little bit about forms, but there's a whole segment in the WCAG standards for forms as well on 3.3. The important part is that forms must use proper semantic structure. All input elements must be actual input elements and have a proper label that describes it in a good way. So, for example, here, you might think that your full name should be sufficient to tell the user what you are supposed to write. But if I struggle with concentration or memory loss, maybe I don't remember what I was supposed to write into this when I begin to write and the information disappears from me. So maybe I was supposed to write only my first name or my full name, or was it only the last name? I don't remember because I have problems with memory loss. So if you just add a label, it will be so much easier for everyone to know what they were supposed to write in this input field. Now, should we accept this? It's probably something important, right? How about now? Do you accept? I think I should, because I know I struggle with concentration, and probably somewhere along the line in this page that I'm visiting, there are some information, and I feel like it's my problem that I haven't gotten that information. So I just accept it just in case. And we'll see what we are accepting later. Now, checkboxes and reader buttons needs to be actual reader buttons and checkboxes written as input fields, and they need to be accessible by both a mouse and a keyboard. And a screen reader and people who are able to see need to be able to view the application and need to know what they are accepting when they are at this application. What you're accepting must be clear. And this example have multiple issues. I have a do accept in a heading tag, which is weird, a heading 3 tag. It's not connected to the input field. I have a label, which is not connected to the input field either. It doesn't have any form or ID or anything. And the question does not provide me any information either. So nothing is clear. And now we're going to see what we were accepting. I henceforth acquaintance to the blood term set upon my soul and person to the oligarchy empire. Oopsie. But, you know, at least now I know what I am accepting. And the, the label is connected to the input. That's good, right? So, yeah, well, I sold my soul, but now I know who I sold it to, at least. Now, there are even more issues related, or WCAG standards related to forms. And here are even more of them: use of color, influence, relationship, label, innate, and headings and labels. And we also have a whole segment under 3.3 that you should check out if you want to learn more about forms. The last segment, the segment of hearing impairment. Now, this is also how it is to experience a website that has information that are only available by sound for every person with hearing impairments, and also every person who are, for example, sitting in an open space without headphones, or for some other reason can't use sound on their device. It's empty. And I have made a video, and warning, I can't use a movie. I didn't want to use AI to make a movie, but I can't use iMovie either, but I tried. So I have made a little silly video, and it has very informative information about accessibility, and you should try to get that information from watching this video. Did any one of you hear what I was saying? No? No, you didn't, because this was totally not written to be accessible at all. So this segment especially applies to videos. And we have some issues, some WCAG standards, related to videos. We have captions, which is an A standard for pre-recorded videos. We have captions for live videos, which is a AA standard. And we have a AAA standard for sign language on pre-recorded videos. And we aren't going to talk that much about that one, but I just wanted to show to you that you know that it's there. So for captions on pre-recorded videos, we have a checklist. Videos has captions in DBT format. They need to have captions in DBT format. The text needs to be both visible and optional for the user. It needs to cover both and important fields. And the language has to be marked, for example, with the source language English. And this is how it will look in code. As you can see here, I have added track kind captions with the source captions EN/BTT with the source language English. And you can add as many tracks as you want to, but the important part is that you at least have a track for the language you are speaking in the video, so that the people who should have been able to get that information if they could hear, get that same information. A captions file will look like this. As you can see there, from 00000 to 002.5, that means from 0 to 2.5 seconds. There's a drum roll, so you can look forward to that drum roll. And then I'm going to say hello and welcome to this very informative video. It was very informative. Today we talk about accessibility. Then it will be some silly background music. So now we get to experience this video, how it should have been, how you should have experienced it the first time. Hello and welcome to this very informative video. Today we are going to talk about accessibility. Yay! So now you got the same information, the very informative video. For captions on live videos, we have a checklist as well. It needs to be real time, enough to follow the event, available during broadcast, and include both speech and I don't have time to go through examples of it right now, but this is the checklist. You know that it's there. You know that it's a WCAG standard. So that was captions for pre-recorded and live videos for you, and also the end of this presentation. And if you are still making web apps and websites that are actively discriminating people from using them, I will look at you like this. I am only sort of kidding because I know that I'm not perfect myself. So I look at myself like that sometimes. But I do want you to try to remember your key takeaway from this presentation. And I want you to get out of this talk and want to make accessible websites. So thank you.
Microphone is coming back up. It's back up. Thank you. Any questions? Raise your hand. Any? I do have a question, which is, are there any tools out there that will help us, that will highlight some very common mistakes in our apps that can just, feed our resulting HTML and it will just shout at us, hey, this is an obvious fix for you.
Yeah, I was going to talk, have a talk about this Pally, PA11I, Pally, which is a tool I use on my slides and my applications, where you can install it in your pipeline as well with Pally CI. and that will scan your page and look for problems. So, for example, if you have too bad contrast or have an image without any alternative text, etc., it will find those issues and give you a list of all the WCAG issues you have on your page. And you can choose the standard. If you want to reach for the AAA standard, you can put the standard to AAA instead, etc. So it's a very good tool.
Anyone else? Okay.
Thank you. I'm going to play the devil's advocate, but why don't these blind people just get an AI to read the website so we wouldn't have to worry about all this annoying shit?
Because AI is stupid. I mean, oh, I'm some AI tools might be good enough, maybe, but I feel like we can trust AI to do that, and it's not only for screen readers; it's for so much else as well, and yeah, I feel like it's a hard question. I haven't thought about it, but yeah, AI does some mistakes, and you shouldn't have to use an AI for something for information that should have been visible for you and available for you in the first place. Was that answer enough?
Anyone else? Yeah.
I know there's so much tags available for us to use. So I wonder if you have reference or sources where we can get to know more about tags, except V3 schools or Mozilla.
Yeah, I have very bad memory, so I just usually Google. If I'm wondering if I can't remember a tag for something, I just Google what I am trying to make and an HTML tag, and almost every time it pops up something that that is the better tag for what I'm trying to make. And I don't remember the name of the website that usually is the best, but it has this blue and white colors. I don't remember the name of it. Yeah, I'm very bad at names, and yeah.
We can Google it.
What?
We can Google it.
Yeah, I can Google it. But I don't have internet on this computer right now. But I can Google it and show you show you it later in the maybe.
Anyone? A big round of applause, please, to Elise. Okay. Just bear with me here for a second. To do only use tables when I want a table. I'm learning a lot today. I don't know about you, but are you learning a lot? Hell yeah. Who wants some coffee? All right, let's take our first break. Let's be back at 11. See you in a bit. I was talking to the next speaker yesterday, and apparently he was part of a team that was building a online. Apparently, there's no issues whatsoever, and everything always worked. For the first attempt, um, it was also very helpful the whole time, something like that. So, please welcome on stage for the first time in React Norway, Costa Alexoglou.
Thank you. Hello, everyone. Cool. Yeah, so nice to be here. Yeah, I'm going to talk about building a pair programming app in JavaScript. And good luck if you do this. It's not going to be easy. So yeah, I applied 6 months ago. Many things changed. We were writing this in many parts in JavaScript. And unfortunately, we needed to migrate. So I will show you how we've migrated and in which programming language, many parts of it. Still, some of them are in JavaScript. Still, they're causing problems. So yeah, the agenda, I will start with who am I, what is pair programming, why pair programming is important, and of course, I'm saying this as a building up for pair programming. Then, what does it take to build a pair programming application, and why it's hard building this in Tauri or Electron. Does anybody know what is Electron? Nice hands. Anybody here have used or know what is Tauri? Nice. So yeah, we'll start with who am I? I'm Costa. I'm originally from Greece, which is interesting. I've already met 6 or 7 Greek people in this conference, which is nice. Where are the Greeks? Yeah. Right now, I'm living in Sweden for the last 5 years, and currently I work at Grafana Labs as a backend engineer. I'm also maintainer of Hop. Hop is the only open source pair programming app, and if you get the pan Hop, it's like Hop on a call. Yeah, that's my social media. If you want Blue Sky, Costa Alexoglou, LinkedIn, Costa Alexoglou, the same. Yeah, what is pair programming? So pair programming is when two people write code at the same machine, so we can have in-person pair programming. So we might have one monitor and two keyboards writing on the same IDE, or we can have a driver navigator style, so one is dictating what the other person should write. And it doesn't want any specialized software. And then we have remote pairing, so you can use Hop, or you might use Google Meet, Slack Huddles, Zoom to perform this, where someone is sharing their screen, and then you might share a camera, and you collaborate together. But we hear pair programming, and we only think about coding. But besides coding, pair programming, it's literally anytime developers collaborate with each other on, for example, debugging on call issues, incidents together, navigating in Grafana dashboards, in AWS console, in Sentry, and all those platforms. It's when we can design together new architectures in Excalibur or anywhere we like to design. And it's also when we have design hands-off with designers. And why is pair programming important? It's first of all we have instant code reviews, and this is really important, especially right now that we are shipping so many slow upload code. At least we can review at the time we are writing. So when you pair programming, you literally have the reviewer next to you. You write the code together, so they have the context, and probably the review process will be so much faster. Besides that, we have better architecture on our project, mainly because we are aligning before we open a PR. As you've been there, you work on something for 2 weeks, and then you make a PR, and suddenly a reviewer comes and say, okay, let's scrap this, let's go with another architecture. And this is super sad. And the next one is better focus on productivity. And this really speaks close to my heart because my attention, the last year has gone really, really bad. And I think it's a global. And And especially right now, nowadays with agentic development, this is like the reality. We had the promise that we're going to be 10x more performant, and we're going to have 10 agents running code for us. But the reality is literally those groups are found in Twitter. We start the prompt, we let Claude Code or Cursor do the work for us, and then we go and scroll, Reddit, LinkedIn, our emails. So it's not like that we are 10x productive. It's just we constantly do a context switch. And yeah, why pair programming solves this problem for us? It's a thing called Hawthorne effect, which is basically dictates that we have different productivity when somebody is observing us. And this is the reality with pair programming, right? If I share my screen or if I'm expected to control somebody else's screen, I'm not gonna compose my emails, I'm not gonna scroll Reddit, I'm not gonna comment super easily. So for me, this is really nice as an effect of pair programming. Yeah, and if you want some extra pair programming benefits, there's an amazing talk from Farhan Thawar, VP of Engineering at Shopify, amazing VP, amazing engineer, and yeah, breaks down the benefits, super nice. Yeah, let's go to the specs of pair programming. So when we started, we looked in the industry, we found some private products like proprietary products and none of open source. And we tried to understand, okay, what does it take to build a pair programming application? And those are the six I could list now. Crystal clear screen sharing, and I will elaborate more on the next slides. Latency below 100 milliseconds. I will also break this down. One-click calls. No. So has anybody here used code with me or live share with VS Code? I can see some hands. So they work really nice only for the ID, but you need to share links, which is really a bummer. Um, drawing support if you don't want to control but just want to annotate. Of course, remote control in keyboard shortcuts. So if I control my teammates' cursor instance, I would just need to press some shortcuts and delete a line, for example. And crisp audio. I mean, we spend a lot of time communicating with our teammates, and we want really good audio. So to give you an example of how Hop looks like, we have up in the menu bar the main application window. So we have, I'm not sure if you capture, yeah. So you can just click and call your teammate. Then we have a screen sharing window. This is where we can control, draw on our teammate's computer, and then we can share our faces if we want, to see our teammates. So let's break down the specs really, really quick. So every time we go and pair in Google Meet, for example, or you screen share because you're making a demo, the very first thing you ask from the participants is, can you zoom a little bit? So every single time it's super blurry. So you end up zooming 10x, which seems abnormal if you're coding, just to make it look nice. So to give you an example, how hop versus like huddles, for example, is above we have hop, below we have Slack huddles. Actually, it's even pixelated here. It looked better on my Figma, but cool. But by default, we serve 4K resolution. We have edge enhancement filters, so we try to optimize for text, so it's crisp. And then we have better compression, and we don't compress so much the image. And I will also break this down later. Then the other spec is why 100 milliseconds latency. So based on Apple guidelines, after 100 milliseconds of latency, of delay of your action, you start to feel something that is lagging effectively, that is not responsive as it should be. So in Apple guidelines, it says 50 to 100 milliseconds. 50 was not achievable at all with network and everything. So we said, okay, at least we need to be at more 100 milliseconds in our latency. And then how do you define the latency your latency, we think, okay, it's network latency, request back and forth. And in a pair programming concept, the latency is defined like this whole pipeline. So let's say that I control my teammate's computer. So I press a key event. Then this transfers through the network to the one that is sharing the screen. It gets executed to the operating operating system. We capture back the video frame. We encode this, we send this back, we decode, and we render. So this whole pipeline of back and forth should be 100 milliseconds. And of course, why crisp audio? I think it's self-explanatory. Those are the three main pillars of a pair programming app: camera, screen sharing, and audio. So it should be sounding nice. And yeah, we wanted to strive for active noise canceling. So yeah, people are working remote, they work from cafes, they work from open offices. So we wanted this to be super nice for them to not be shy to open the microphone. And clear voice quality, because you may spend up spending 2 hours pairing together. So we wanted this to make this enjoyable. And now we will break down why it was super hard to achieve with Tauri or even with Electron. And I will break down three problems effectively. How we achieved 100 milliseconds latency, crystal clear quality. Why WebKit's audio sucked. Who knows here what is WebKit? Okay, most of you. So WebKit is the browser engine of Safari if you're on macOS, and the ghost code problem, which I will break down in a bit. So yeah, super quick breakdown of what is Electron 3 and their main difference. So with Electron, you have a main process, and then you control some Chromium instances. So every window, in our case, we have the main screen sharing, and the camera window would be theoretically its own Chrome instance. And with Tauri, it's a little bit different. So wait, it uses the web views of its operating system. So in our case, it was WebView 2 for Windows, which is Chromium based. It was WK WebView on macOS, which is like what Safari is based, and WebKit GTK on Linux, which is a port of WebKit on Linux. So that's the main difference between Tauri versus Electron. And also, main process in Electron, you can write JavaScript, Node.js. In Tauri, it's Rust. Yeah, and hopefully after the end of the talk, you will understand why we needed to migrate on the version one, the first stable version of Hub, many things from Tauri to the Rust backend. So in our case, we kept the main window in Tauri. Not sure if it's useful, yeah. But screen sharing window and camera window all moved to a native Rust implementation, even the view, which is really, really hard to write graphical user interface if you compare with Rust, CSS, and all the goodies that come with it. But it was worth it. So yeah, the first problem we needed to face was how to measure latency. So we used WebRTC, and and it was really hard to measure all this pipeline. How do we actually measure this? There was not any primitive to make this happen. So what we did to hack this out was a watermark hack. So we were sending artificial events. So we were naming this tick event, sending this to the network. We were capturing the video frame. So if we read that there was a tick event, we were watermarking the video frame. So you can see here on the top, there is a black strip. So this was an indication that we annotate the frame. We were encoding this, sending this back, decode the frame, and then if we detected the black strip, we knew that this was the full loop, so we could measure the latency of the tick event. So that's how we were actually measuring how things were doing. So if we've done this initially with WebRTC, and on each frame on JavaScript, we would have a callback to basically figure out the first rows of the video. Another thing that we faced when we started inside the WebKit's context was that the default WebRTC settings in the browser are not meant for real time. So browsers ship a WebRTC distribution, which is a generic optimum for plethora of cases, but basically everything about it is about conferencing. So camera and microphone, conferencing across many devices, networks, and battery profiles, but that's their optimum. Would think of, but for the remote pairing one, which is the local optimum, is conferencing across limited number of people. So you're not going to be 20 people in a room coding together. So you're going to be 2, 3, 4 maximum. Clear image, super clear image, super low latency, and good audio. So yeah, we tried hard to make it work from the browser, but we could not reach the 100 milliseconds in any case. And the browser limitations we had was that we don't have really good codec support. So codec, for example, in WebKit does not support AV1 in older MacBooks. So if you wanted to use a super performant one, in our case AV1, you needed to have M3 and later versions, which was sad because that meant even if one participant didn't have an M3, you needed to go to a previous codec. It does not allow codec knob configuration. So if you want to tweak the codecs, and this makes a huge difference, it does not allow from the browser context. Does not expose an e-screencast flag. We'll also break this down, and we do not have low access to the image buffers. And this is for future work we are doing. So yeah, what we hacked here effectively, so we can see two axes, high resolution, low resolution, and slow to fast. So in our case, we want to move as much to the top right as we can. And the first thing we changed was something in the codec called quantization. Quantization is when you change this, it means less compression. So it really improves the clarity of your image. Yeah, in our case, that was the most important configuration to make it look super clear. So you don't need to zoom when you pair program with your teammate. So yeah, if we have the default browser here, it moved us vertical to a really high resolution. Yeah, the next one that we didn't even know it existed, browser never exposed it, and we found this by mistake. It was a flag in WebRTC, literally called screencast, which in our case slashed the latency by multiple milliseconds. And they even have comments here. It has its own trade-offs. It's not about screencasting video content, but it's about screencasting documents, code, things that are fairly static. And the last one was buffer sizes. And in our case, when you reduce the buffers, you have faster feedback. So that means against faster feedback loop, lower latency, which come with its own trade-offs. You can have higher artifacts. So if you change windows like this fast, you might have an artifact in your screen set, or if you screen share a video. But in most cases, pair programming is about watching your IDE, watching a dashboard. It's fairly static content. So with those three changes that we've made outside the browser's context, so this all happened in the backend in Rust to control the WebRTC primitives. It made us slash from a default of 153 milliseconds, go down below 100 milliseconds, which was the initial threshold that we wanted. And yeah, we have a really nice blog post around all the exploration of how we achieve this. And yeah, the really nice part is that you can achieve this latency even with 4K resolution, which is really nice. So that was problem two. Yeah, the other problem we had, again, if you remember, we want crisp audio. Literally everybody hated the audio in the version 0 of Hop. So you can see some comments. First of all, no audio, the sound is a bit off, output sound suddenly stopped, audio was a bit compressed. So this was really bummer for us because when you literally we could do nothing in WebKit and Safari to fix this. And yeah, audio sucked. Eventually, why audio sucked? So this is the only React component I will show in the presentation, unfortunately. But yeah, so from LiveKit, they had a component called Start Audio, which when we found it, it seemed bizarre. Okay, so it says that the browser blocks audio playback. This is due to some browsers implementing autoplay policies. So in some cases, you will need to explicitly click the button so you can start hearing your teammates, which was a bummer. Even though, for example, in Electron or in Tower, you have an autoplay policy that you can inject to always play, still it was flaking. It was not working. And some other bug, which is like a bug that is for so many years. So WebKit Safari was converting any audio to mono when you were in a WebRTC call. It also had a glitch every time you go, for example, if you go to Google Meet and you try to list microphones while you listen to something on the background, it will make a weird glitch. And yeah, the active noise cancelling was okay. So it's not the best, but it was working. So yeah, again, version 1, we needed to move everything outside of the browser to a backend implementation, which for us, this solved the most for the playback, no glitching, and better noise cancelling. For noise cancelling, we used this big boy, DTLN, dual signal transformation, which is a CNN-based model. And it was real time, so that's what we wanted to be real time, light resource usage. So you use your ID, you use sites, and so we wanted to have the minimum footprint we can have in the resource usage. And it's actually really good for noise cancelling. And if anybody used the Z here, this is the model they were using also to do noise cancelling. And for inference, basically executing this CNN, we use Tract, which is a library provided by Sonos to do inference of your models, which works really nice, minimum runtime needed, so it worked really nice for us. Yeah, and the last problem we faced, it's called the ghost calls. A ghost call occurs when your phone rings, you answer, but you hear only the there or silence in the other end. I'm not sure if it happens to you in real life, if a spammer is calling you and nobody is speaking. So it was basically this happening in Hope. Yeah, so we had many users complaining that they received calls, they answered, and they could not hear the other participant. And in some cases, while we were debugging with the users, we were trying to understand what's happening. In some cases, the other participant was not even calling at that point in time. So we were trying to figure out, okay, what is happening? And yeah, to give you context how Hope works. So we have the main application, which is a web view. Think of it like a browser. Um, so you're on a web page and you connect through a WebSocket to the backend. And this backend has a connection to Redis, so we can list which user is online. So the real example here is that we have user 1 and user 2 connected at the same time in the backend. Then there's a connection to the Redis, and the flow in reality looks like this. So user 1 clicks to call the user 2, we send a WebSocket message, and then we say to the backend, does the Redis connection exist for user 2? No. Okay, reject the call. Does it exist? Yes. Send a WebSocket message to user 2. It sends a message. Did the message succeed? Yes. Okay. You wait for the reply, else you reject the call. Anybody wants to take a guess in the bug here? And stop if you find any. Else I will ask Claude. Okay, I asked Claude, literally, make no mistakes, find me the bug. And it hallucinated fully. So it couldn't find any actual bugs that were happening. And yeah, the insights came after we had a call with a user to tell us exactly what they did to reproduce this issue. And that was a really weird one. So what was actually happening is that in this example, we have user 1, and they were clicking to call the user 2. And user 2 was perceived to be online. So um, when you close your MacBook to go into sleep mode, for some reason the WebSocket was still alive, so the TCP connection was alive, but yeah, JavaScript runs on an event loop, so this event loop was frozen. So literally the TCP packages were getting read, so the backend was succeeding in sending the message. Every package was delivered, but it was not actually getting executed. So I had my MacBook closed. Somebody called me. I received the packages. They stayed there. And then after 8 hours, I was opening my MacBook, fingerprint, it opens, and then Hope was ringing. But of course, nobody was there. Nobody was calling me. So I received a call from the past based on this weird issue. So that was a really, nice one being in the Tower Woodland. And yeah, those are the problems we faced, or we still face. This was currently in version 1 in the main application window, and some extra things that we are working right now, which is really nice stuff, at least for me. It's upscaling. So upscaling is having a lower resolution and increasing the resolution of the CPU for literally 0 milliseconds cost. It's really fast, especially in Apple's GPUs. So in our case, a user you can think of can share in 1440p, and then we can upscale this to 4K with zero latency penalty. For us, this is feasible in the Rust context because we receive frames from the WebRTC. We have access to the low-level buffers. We send them to the GPU, and we live our lives. And this is really hard to achieve in the browser's context. And of course, this will mean better latency for the users because if you share something in low resolution but still receive 4K, it's really nice. And just to give some props, you can do this in the browser. So there's an amazing talk in the MUX from John Bartos and James Harley, real-time video super resolution. So this is the Twitch engineering team. They did super resolution in the browser context, almost real time. So they used web GPU and web codecs, but to achieve this, they needed to train their own convolutional network to address performance issues. So basically, to make it super real time and lightweight. And for us, that was a bummer. That first of all, it would be 2 frames behind, so that means 33 milliseconds latency minimum, while in the native solution you have 0 milliseconds latency. And yeah, if you know Safari, if you're a front end, you know WebKit is always super late in adoption of any spec. So yeah, to play with web GPU and web codecs, it would be GG for us, feasible. Uh, yeah, it's open source. So yeah, spread the word, give us some love, smash the start button, or not start, if you can. Um, yeah, and that was it. Thank you very much.
Awesome. Any questions? Some questions.
Hi. I'm just wondering when you measured the latency, I'm guessing you had several different computers. So I'm wondering, how did you synchronize the clocks on each computer to know that the reading was accurate?
Yeah, to synchronize the clock is a pain to do. So in our case, we just sent in our test. So first of all, the test can be done with your own computer with 2 instances. So you can just send to a live kit web server and have 2 instances running and measuring. But even in other computers, so when I was testing with my friend, the only thing you can do is just pass a UTC string and pray that you will not have a huge skew because yeah, there is no other way you can do it. We were not doing super fast stuff.
Okay, cool. Thank you.
Anyone else? All right, right on time. Thank you, Costa.
Thank you.
I really like the title of the next talk, which is "No researchers were harmed in the making of this test suite." I would hope not, but have you ever harmed any researcher? If so, let me know afterwards. Um, so UX research, sprint cycles, they don't really go hand in hand uh, very well. The next speaker one will give us some suggestions how to automate some of it and get some real user behavior data in days instead of weeks. So please welcome Dora, Makszy.
Hello, how are you? How are we doing so far? That's good, that's good. Okay, let me do the screen mirroring thing. Hopefully that will work. Of course not. Could someone help me, please? Yeah, so I do not have HDMI or anything, but USB-C, that's great. Cool. Okay. Something is happening. Right? You did it. Thank you very much. So big applause. Thank you. So I asked you how you are, not just because this kind I am, although I am, but because I'm a designer. I'm a designer of Element Logic, and at Element Logic, we are dealing with management softwares. We are developing them. I don't know what you know about warehouse ecosystems, but they are quite complex. And this means that if you set up a warehouse anywhere in the world, it's going to be huge and has a huge hardware requirement, as well as the software that will orchestrate it. Now, at Element Logic, we are over 1,000 people across the world, yet our design team consists of now 5 people, including me. Last summer, when I actually had this problem that led me to this talk, we were only 4. And out of the 4, 1 was permanently missing, and the problem hit in July. Now, I don't know how many of you are Norwegians, but in July, Norway gets cleaned up because of hot day seasons. So I ended up having a problem. Then I utilized some theory and methodologies just to solve this problem, and I ended up building a tool. And with that tool, I was able to solve the problem, and so I wanted to share my results and the value this tool will give, so you will be able to rebuild this tool and use this for your own purposes. So the problem, we did not have available resources. We did not have a dedicated researcher. Why is it a problem? I will tell about it later. We had too many unanswered questions and very limited time. What I haven't told you so far is that last year we kicked off a huge project. So far, Element Logic had multiple separate products that solved different parts of warehouse orchestration. But now, with this huge project, we wanted to connect all of these to provide a complex ecosystem for our users. We had to start from scratch, and we also wanted to answer some questions and user problems that we heard back from our clients. And to solve this problem, we have a very tight deadline. Now, when I speak of limited time for many unanswered questions, I'm speaking about having one single month, that very July, to come up with some well-educated decisions so the development can actually kick off in August. And we needed evidence, not opinions. It's very easy to say that, well, I think that this was better, like in purple or something. We didn't need that. We wanted to know for sure that warehouse workers can and will use our software product. So what a designer does in this kind of situation is that we are shining like a diamond. I don't know how many of you have heard about the double diamond method. That's good. I'm amazed. That's great. So double diamond consists of, surprise, 2 diamonds. The first one is the problem space. The second one is the solution space, meaning that when we are opening the first diamond, we start to diverge. We have a problem, user feedback, a business opportunity, and we start to figure out, okay, what else do we have around that? And we draw up an opportunity tree with all the related opportunities, and opportunity is a well-stated expression for problem. And when we have enough opportunities, then we start converging, meaning that we are gathering and documenting all the assumptions that we have regarding those opportunities. Now, when we have enough, we, at the end of the first diamond, we start to put certain solution ideas to the most, the strongest assumptions and strongest hypotheses. And with those solution ideas, we open the next diamond and we converge again. We create a prototype with which we test. And then during testing, we start to listen and collect the feedback coming from our users. So we actually gain a lot of knowledge and a lot of information just with this simple method. Now, UX research. Many companies that I worked with were established by engineers, which is cool. Engineers have great ideas. And you also do have a lot of technologies at hand. So when you figure out that there is an opportunity and you have an idea how to solve it, you might immediately jump into the solution space and just build it, launch it, and then get the feedback after. And in most startups, for example, it works quite well. I've been working to a company in Norway where the original idea worked so well, they built up a whole company, worked for 10 years, very satisfied users. But when they started to establish more products, more solutions, they forgot to involve research and they got very bad feedback, so bad that this is now bankrupt company. So this is an expensive mistake. Instead, what you can do is that you involve a designer, researcher, full stack designer, however you call it, and ask them to get feedback before building your very first app or writing even the very first line of code. So this way, you can get educated decisions. The designers could make developer-friendly solutions, which will lead to better products. What methods can we use for this? In UX research, there are a few methods, but I will demonstrate a few solutions. We know A/B testing. Probably many of you know it. There is a new feature that you want to roll out, so you can just test with a bunch of people, and you roll out version A for the first bunch and version B to the other bunch, and then you get feedback which one was better. There is also another A/B testing methodology when you just ask the users, okay, here are two different designs for the very same, for example, banking application. Everyone has a banking application. Which one do you like you best? Um, for example, traditional design or the modern design, and they can just click on the one that they like. The other one is first click testing. When you are establishing a very complex website and you want to make it easy to the user to navigate across the website and you want to guide them, it's very important where do they look for the first action. So with first click testing, we can just figure out, okay, in the middle, on the right bottom or the top left corner, and we can just record their answer, their click. Now, there is card sorting, which is for information architecture. When we are establishing a very complex ecosystem where one of the most relevant problems is navigation, how do our users navigate across the system, then it's very important to know that, for example, in our case, a warehouse manager worker, how do they think? Where do they look for certain activities, certain concepts in an ecosystem like this? Our exact problem was to solve this navigation, and we wanted to sort the relevant information according to categories. So this is what we are doing here with a simple example, operations and setup. Dashboard, I'm operating stuff from the dashboard, so that's operations. Analytics, okay, I'm a warehouse manager, so I'm putting analytics there. Settings, now that's a tricky one, but I guess this is a setup instead. Profile also, and then reports, probably operations again. Bam, I solved the categorization with just 3 seconds of time. And then there is misclick detection. Again, when you're working with a mobile application where you have very limited space because you are optimizing to very small surfaces, then it's key that when your user actually want to perform a task, a very important task, for example, saving a banking document, the buttons should not be very close to each other or very well separated from each other. And when it comes to prototyping, we can test the misclicks. I wanted to save the document, but they are so close to each other, I click delete. And then I try again, but I clicked again on the wrong side. So when I finally hit save, then it counts as a success. Again, quantitative results that I can record. And finally, when it comes to efficiency, when I want my user to perform a task, again, setting up something, I can count how many clicks it will take for them. For example, I go into profile, onto preferences, on a notifications page, then I want to turn on weekly reports, bam, I hit the toggle, and it took me 4 clicks and then closing the menu item. So then again, it's 5 clicks just to turn on and off the weekly reports. But it's again a quantitative method for me. So with this in mind, we established a few hypotheses for our software, our warehouse management software. The first one was that users understand ecosystem structure. So an assumption could be as vague as this, but a better, but the more precise your hypothesis is, the better. So ours was users understand ecosystem structure. For that, again, we were looking for some information architecture solution with which we could go for category grouping. Now, when it comes to navigation, it's being intuitive. We wanted to be sure that first click testing shows us very well results. Where do users look for a certain navigation point? And with this, we measured accuracy rate. When it comes to task completion and its efficiency, we went for click count and we counted the average clicks. And if users prefer the news design, we were going for A/B testing. Now, when it comes to warehouse management softwares, warehouse management industry is huge and developing slowly, meaning that our current products are, how to say it politely, not that elegant. And but they are efficient. They use blue and yellow and huge rectangles and basically enormous buttons. And the users, operators who are standing at the port and performing their tasks, they know exactly where to look and where to click because they got used to that too elegant design. So when we were going for redesigning, we had to take that in mind. And it turned out during A/B testing that there is a preference rate. So the final hypothesis was interface elements are clear. So we checked the misclick detection and we measured the misclick rate. With that in mind, we started some experimentations. What I haven't mentioned yet is that last summer, Figma rolled out Figma Make. In the age of AI, we are exposed to this, especially in this industry. So obviously, we started to experiment with that, especially because the tokens were free. So we were like, okay, we have a few hypotheses. We just test out something. And we ended up with this. This is a prototype for how to test usability. So, okay, I type in my name. I'm an operator in a warehouse, and I have 2 years experience, so begin study. Okay, I will not read this bunch of text, right? Nobody cares. So I just started task. Okay, so where did my task go again? And then, oh, here it is. Okay, generate a stock movement report for the post. Where the hell should I do that? I don't know. So I just look around, try to click everything, and I cannot. So there is a big green button. Great, I click it. What do I think of this? Whatever, I don't know. I cannot see the top. Okay, that is crazy. That I just won't finish, right? I just hate it as it is. So just to show you the rest of the test in a very quick way, and I really hope that this will speed up. Yes, I even wrote a very bad message for myself that this is not good. And then, I'm sorry, but the video won't be quicker. Or right now, I try to read again. Okay, now we both forgot. This is the whole prototype. This was what I did. And then at the end, when I was asking for overall system usability, this is what happened. What is this white space? What is happening there? I was like, what? No, this is not what I wanted to do, right? So I just realized that this is a failure. And not just testing without clear hypothesis or choosing the wrong UX research method, because I haven't told Figma Make which method to choose, right? I haven't prompted it accordingly. I just typed into Figma Make, that I want to create a prototype with which I can test usability for warehouse management software. That was my first prompt for Figma. And that is okay. That was a bad first attempt. But when the second time you get with misleading or biased scenarios, if you are working in an environment where majority of the stakeholders have multiple tens of years of experience, they will be biased, even though they know the whole system very well. They will have their own preferences, and when you or whatever role you are in want to establish a prototype and ask questions, it will come with biases. You can also fail by measuring interactions without understanding what they mean. So that is why probably it is nice if you read after these methodologies or have a researcher at hand, and confusing preference with usability, again, being biased. Quantitative data used without qualitative. So it's nice that we can count the clicks, but what do they actually mean? And how does the user feel during the testing? Does it make them confused? Does it make them, feeling alone? How, how do they feel? It's relevant, although it's not measurable. And then, yes, Figma Make provide us with so polished solutions. It was very easy to believe that that was the final product. So much so, when we were working on another prototype that we wanted to have as a North Star prototype for the whole ecosystem, some of the developers were frightened that this is what we wanted to make them to develop in 3 months. And we were like, no, 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 this is just an idea, this is where we are going. It has a lot of features that we will have in 2 years' time. Okay, but it's confusing, so please make it stupid or something. And that was the other problem, right? Make it stupid. And then finally, and this is why I call myself as an AI skeptic, is that when it comes to critical thinking, it's so easy to believe what AI says, right? But in this case, when we are testing actual user feedback, it is just the most important thing. So how do we end up with an actual usable tool? And this is where I would suggest to follow the craft method. What does it mean? It means that a few concepts like giving the context, the role, the action format, and target audience, you're basically defining for the AI tool that you're using for building another tool what you want to build and how you want to build it and who you want to build it for. And with this model, with this craft model, you are making your definition so precise that the AI, the generative AI solution, won't end up providing you with that many bad iterations. And something that I learned during the way, and I wanted to show it to you, is that there are some tricks. And works with Figma Make, that's for sure, but I think it works also with Codex, with Claude, so you might want to try it. First one, start with perform only the following changes, and then you start to explain what and where, and just refer to the exact place. And finally, close it with do not change anything else. And this was very important learning that I have to talk to AI like it's a 5-year-old kid. Otherwise, it will start hallucinating. And for example, after the, I don't know, 10th iteration of my prototype tool that I built, I added a new prompt, and then finally it started to look like, yeah, this is it, we are going the right direction. And in the next prompt, it basically vanished. Nothing of my previous 10 iterations was there, and it's like, what the hell? So I added this prompt, do not change anything else. And since then, so since 1 year ago, I use this prompt back and again and again. And since then, I have more precise prompts. Maybe it's just rocking my world, but it works for me. So finally, I ended up having this proper tool with the proper user scenarios and proper methodologies in place. So this is what we have shared with our users. this is where we started. We gave some introduction. What do they need to do? They have to record their session. I will talk about that later. They should have worked naturally, meaning that if they are recording themselves in their screens, they just have to tell me, like I was in the same call, what they are doing and how do they feel. And then afterwards, they need to share their results. So, okay, they have an overview of what they will have, and then they start a module. Now, this is something what actually looks like a dashboard of warehouse management software. And these are the menus. Okay, now we have it there. And okay, I do have the prototype stuff here, like the time elapsed, the completion, the actual task. All right, start testing. John Doe has been absent for 3 days, blah, blah, blah. I'm looking for John Doe. Where would I look? If I'm a warehouse manager, which is not clearly stated in the task, but the actual users know that they have to test like a warehouse manager, where would they look for John Doe? Either under admin or in the search menu, which could be John. Oh, there you are. And so I click it and I can see that, okay, now I can call John Doe. Why is he missing? And the completion already went for 25%, which means that I will have more tasks. I won't go through the whole task because I can have video and hopefully this will work as well. So fairly quickly going again through, looking for John Doe. Yes, figuring out where he is. There we go. And now we are looking for an order. Where would we look for an order? Probably under outbound activities. Whoa, there we go. So I click it, I found the order. Okay, next task. I'm annoyed by weekly reports. The time is ticking, so I have to be fast. This is a personal setup, so I'm looking for settings, weekly reports. Good, I found it. And then, okay, now I have to click start task again. This is a glitch. And then the manager is interested in the output. Oh, there we go. There is the output. So I share it with my manager. And this is one very important thing that I wanted to show, that after each module, we are sharing the partial results that are already exportable from the system, and it actually works in CSV. So we are moving forward after celebrating that this is giving us back whatever we are interested in, and we are engaging with our testers. And this is how card sorting looks like in a more complex environment. We collected 44 concepts and actions coming from the warehouse management system industry, and we started to categorize them under these certain categories, and we even created new categories, which made sense at that time. I didn't want to torture you with looking through all the 44 items, but here that is very important that we can give back subjective feedback if, with this tool, with rating and are we satisfied or not, meaning was this simple enough for you to perform the test? And did it make sense for you to have the information architecture of this? So again, we do have the partial results. We are having the final tasks, and it will pass them up again. We simulated task, we performed, and then we are going for the final screen where we have all the results from all the tests, every single clicks, actions, average time, feedback, categorization written down, and it is even exportable in CSV, meaning that once we had the participants record themselves and share their screens and narrate themselves and send us the data, we could have actual CSVs at hand, which we could then export, consolidate, aggregate, and analyze. And this is where human being and human resources are involved. And this is where we haven't harmed any researchers during the project, sorry, because we just pushed this testing to the users who actually enjoyed it. It was so fun for them. They were getting back to me, okay, when's the next one? And here comes the fun part. When they actually knew how to use the tool and they were available to export the data and could finish within one single week with the testing. I don't know how many of you knew how UX research works, but it could have taken months. And now we finished within just a week. Together with building the tool, 2.5 weeks. The remaining time went for iterations, better scenarios, and testing it out with internal stakeholders. It was crazy because AI handled the busy work, while after analyzing and drawing conclusions, we, the design team, together with our respective product teams and engineers, we handled the critical thinking. What do we learn from these tests? We combined these async quantitative data with in-depth qualitative interviews, meaning that that very brief testing time allowed us to focus on those users who mentioned something during their own self-recording that's worth our time calling them back for an in-depth interview. And this was very relevant because normally it's a full-time job to be a UX researcher. And with this presentation, I'm not saying that we do not need research. We do need researchers. It's just when you are alone in a team or when you do not have the opportunity to involve a researcher, I still would like to encourage you to make educated decisions. So we reduced time to insight and we had data-driven decisions. And what's most important from the business perspective is that we lower the risk before writing the first line of code. And with this, we also established a reusable and scalable tool. Why do I say this? Because one of my colleagues actually copied my Figma Make file, give Figma Make different scenarios, but kept the time counter, the click counter, and whatever. And he was able to reuse this for his own scenarios. So that is why I was, yeah, um, I was thinking that maybe it could be interesting for you as well. You could rebuild this, meaning that you define a problem, chose the right methods, decide the metrics, build a prototype, collect results asynchronously, export the CSV, and analyze the results. There are some best practices. Again, the craft prompt and take AI as a collaborator, not a decision maker. Start with clear assumptions and clear hypotheses. Measure the observable behavior and not the opinions alone. And the prototype failures are, yeah, cheaper with these token prices. I'm not quite sure anymore, but still might be cheaper than an actual whole organization failing with a new product. Here you will find an simple craft prompt that you can interchange according to your needs. So it's easy to copy and paste. And this is where you can find it. On the build your own, you can just end up on my website where it's inbuilt, this presentation. You will find the points there. You will find the prompts there and the best practices. And on LinkedIn, well, I do like to have friends. So contact me on LinkedIn. Thank you.
Thank you. We have time for one question. No questions. Thank you.
Thank you
Dora.
very much.
Thank you.
There was a question. Sorry.
There was a question. Sorry, I didn't see you.
So you're building warehouse software.
Yes.
So how do you account for the different in context, moving around in a warehouse with, I don't know, gloves on a old Zebra device compared to what you get out of your Figma Make prototype?
I'm not quite sure I got the question right.
No, so the way you interact with the device can change.
Yeah.
So things like misclicks can depend on whether it's a someone working in the goods reception with
Yeah.
gloves on a winter day
Yeah.
versus someone sitting in a
Yeah,
clean environment.
I gotcha, I think. So, and that's a very good question, actually, because it refers back to the WCAG presentation by Elise as well. And I wanted to mention that in warehouse systems, the operators who are standing at the port wearing a glove, as the gentleman said out loud, they are also usually using a scanner tool, which has a clicker and enter button, meaning that even in that big glove, they will be able to click and basically hit enter. And the other thing is that their displays that they have at the port, it's probably a touch screen, meaning that we should design specific components big enough for them to click it. And in our company, we do have a test center where us designers can go down and check out what we have designed. And if it's too small, not that bright, not that sharp, not that accessible, then we go back to the table and start all over. And we also work together with developers who can show us their solutions. So when we are having a design review, for example, we will have it again in the test center. And we also will go to our customers to test together with them. So I hope that answered that question. If you have any
That's a
further,
great answer. Thank you.
thank you very much. If you have any further questions, then come find me. All right? Cheers.
Thank you, Dora. Okay, I want to ask you a really quick thing now. Think about the project that you're working on, whatever that might be. Think now about a line of code, maybe a chunk of code that maybe you think, yeah, I could delete these. We probably all have them in our code base. And now I want you to do it and deploy to production right here, right now. Maybe not a good idea on a Friday afternoon, but so it kind of feels comfortable to think, hey, this code is not needed. But when we think about, should I remove it? Maybe not now. I will do it later. So to talk about this, Dominik will show us how at Sentry they removed, I think it was around 28,000 lines of code with, I suppose it's a tool called Knip or Knip. Knip. So please welcome Dominik Dorfmeister.
Thanks. Where's the HDMI cable? I can try this one. That's black. Okay. I tested with the other cable, so. Oh, it's this one. It's right here. Okay. Oh. There it is. Yeah, it's perfect. Okay. Hey everyone. I know that I'm like the last person between a room full of developers and their lunch. So I'll try to make it worth your while. But still, before we get started, I would really like to take a picture of the audience, as I usually do that on my talks. I plan to share this on social media, so if you don't want to be on this, now is the time to get out of the way or hide your face or something. Other than that, please give me your best, rock and roll gesture or whatever you have. Yeah. Whew. Thank you. That's great. All right. My name is Dominik. I'm a software engineer from Vienna, and you can find me as TK Dodo online almost everywhere. I have a blog at tkdodo.eu where I write mostly about React and TypeScript. And for the last 5 years, I've also been maintaining the open source library handstack query, or React query as it was known before. Now, really quick question, who has worked with handstack query before, or React query, if I can see the hands? Yeah, there's some hands going up. Okay, that's awesome. Thank you so much. I'm not here to talk about React query today, though, because beginning of last year, I joined the design engineering team at Sentry, where we're not really working on a specific part of the product most of the time, but instead our goal is to make ship happen. So we want to enable other teams to ship efficiently. And in that sense, I see myself also a bit of a developer experience engineer. And our team actually aims to make two things possible. We want to make it easy for the product teams to ship the right things efficiently and consistently, and at the same time guide them towards not shipping the wrong or inconsistent things and get them into that bit of success per default. Now, a big part of our team's job is therefore building a design system, a library of consistent components with good APIs and documentation and accessibility and type safety built in, because components need to be easily discoverable so that the product developers can compose them and ship fast without breaking things. But for the second point, we're actively working on constraints, which means setting up linting and TypeScript correctly, but also improving the project structure and documentation and teaching play a role as well, and also having AI skills these days. So in a nutshell, we are trying to get the overall code base at Sentry that has grown organically over at least 10 years into a good shape and give everybody, people and their agents, the tools to ship fast. Now that means we have to touch a lot of parts of the code base regularly. Like for example, on my very first PR at Sentry, I touched over 900 files because I enabled the no implicit ND compiler setting, which I was really surprised that this was not turned on, and it was like a really big PR. And while I did this and other improvements to the code base, I sometimes wondered if I should maybe sanity test or QA the things that I was touching, try to find out where they are used. And sometimes it turns out they weren't used at all. So one example is when I introduced the ESLint plugin query, which contains our official ESLint rules for working with React query, which I can really recommend you also using if you're using that library. And I enabled that, and we got some violations, tried to work through them, and I found this one custom hook that I battled with for a little bit, fixed the violations, then tried to find out where it was used. And it turns out it was not used at all in the code base. So that's when I thought to myself, no more. This is slowing me down. I'm wasting time here. We have to clean house because unused code has a real cost. It means that developers will spend time reading and trying to understand, maybe even refactoring code that shouldn't be there in the first place. And this becomes even more important in the age of AI, where generating extra code is usually cheap, but maintaining it over time is very hard. And every unused line of code still consumes tokens and might bloat the context window of agents. Library upgrades or changing lint rules also become more painful the more usages we have to adapt, because those tools don't care if code is used or not. If it exists, it has to be error-free. And it might even increase your bundle size if code is not properly tree shaken out. For example, if you have side effectful modules. So all in all, I think it's a pain. It will increase the cognitive load and it will slow us down. And those are all reasons why we should care about not having unused code. So how did we end up here? I don't think it's because we're lazy. I like to believe that engineers are actually responsible beings who like to clean up after themselves. But in reality, we have to actually be reminded about the most basic forms of cleanup all the time. And I also think that we are rightfully so driven by errors, because TypeScript has given us a lot of confidence. One of the biggest advantages of TypeScript is that it takes all the dependencies that used to be in our head only and makes them explicit in code. Like when we have a function and we change what it returns, we automatically see all the usages we have to adapt. And in big code bases, in plain JavaScript without types, this was actually really hard and horrible to do. And with TypeScript, all of this becomes explicit, which is huge for our productivity and confidence. But I think we've also come to rely on this a lot. And it's not just TypeScript, it's also the linting and the testing and all the other static analysis and guardrails we have set up in CI to help us with that, right? If the thing that we're doing doesn't show up as red somewhere in our CI pipeline, it usually means that we're good to go, and we're not really going to look any further than that. And I think that is how plain and simple that code sticks around. If nobody tells us to remove it, we just won't do it. Okay. You might be thinking, well, wait a second, doesn't TypeScript already catch this, right? There's my good friend TS6133, something declared but never used, right? I think we see this all the time when we forget to remove an import or something stupid, and then we get type errors. So I think we should be good, right? So the answer is yes and no, because let me show you a quick made-up example. We have a React component, file size, and we have a local util function that's doing some formatting. Now, if we remove this component, TypeScript will tell us that we can also remove the util function if it's the only usage, because it's a local util function. And if we have, I think the flag is called no unused locals, that we have turned on probably, then TypeScript will tell us that we can safely remove this function. But what happens if we change a tiny thing? If we add an export statement in front of that util function? Then TypeScript will not report any errors at all, because TypeScript just doesn't do cross-module usage analysis. So if something is exported, TypeScript would just assume that we will use it somewhere else, and it will not report any errors on it. And I think that's a problem. It might not be in this simple scenario, but in practice, what happens is that these two things kind of like tend to drift apart. You might move them to their own utils file, and then maybe somebody else in a different team wants to use it, so we move it to a shared global utils file, and then we get multiple usages. And over time, we remove a usage again, and then when the last usage is removed, we don't know that we can also actually remove this util function. And that's how that code stays behind. I think it's the easiest way to produce that code. And also AI does it all the time when it takes one approach and then takes another approach and leaves the old code behind. It's a very easy thing to do. Now, good IDEs can help with that. For example, IntelliJ creates an index of everything, and then it will mark some unused code as visually in the IDE. But it's still up for us developers to act upon that. And I thought, well, this can't be it, right? Surely somebody else must have had the same problem and maybe build a tool for that. And yeah, it turns out there are quite a lot of tools actually. And tools like tsprune or unimported have existed for quite some time. And what they all have in common now is that they are either archived or unmaintained. And they recommend to use Knip by last couplet instead. So what is Knip? Well, Knip is a comprehensive tool that statically analyzes your code for unused files, exports, and dependencies, and then reports them to you so that you can safely remove them. It is quite fast. It takes around 6 seconds in the Sentry code base, which is quite large. It aims to be zero config, even though you might need a little bit of configuration in larger code bases. And it has a lot of plugins and support for monorepos and also auto-fixing. I think that's a great sales pitch, but how does it actually work? So at its core, Knip needs to know two things. It needs to know which files are part of your project. And which files that are usually depends on how you have set up your project structure, but it can be as easy as all the TypeScript files in your source directory, right? And then the second thing it needs to know is what are the entry points to your application. And entry points vary drastically between which framework you're using. So for example, if you're building with Next.js, every page.tsx or layout file in your app directory would need to become an entry point. But if you're just using Vite, in a simple example, it might just be our main.tsx entry point. And once Knip knows that, it will start to traverse the project, starting from the entry points, and then it builds a graph of the used symbols that are imported in those files. And then it will simply report on the things that are in your project, but not in that graph. So here in this simple example, we have like 3 entry points, and some things are used, and then those 2 red dots will be reported because they're in the project, not in that graph. And that's pretty much it. And it works remarkably well. But the next big question is then, like, where do those two things, project and entries, come from? And how can it aim to be zero config? Well, the answer is it tries to auto-detect what you're using with its plugins. And to do that, it will start scanning your package.json to see what you're depending on, and it will try to configure itself accordingly. For example, it might see that you're using vtest, which means it will look at your vtest config file to see which are your test files, and then it will add those. Or it might see an Astro project that you're working on, and then it will try to infer the entry points from that. And for each of those technologies, Knip has a separate plugin. It's now over 150 plugins that it has. And what they mainly do is they try to automatically add things to project and entries so that you don't have to do this manually. So for example, if we drill down into vtest, it would add this configuration because that's how vtest works per default. But also, if you have a different config file, it would read that and parse that to try to find some more reference dependencies and produce more entries if necessary. Okay, I have prepared a short demo. Let me best show you how it works, if the demo gods are with me. So, right, so this is the Sentry code base that I have checked out. Sentry is open source. It's available on GitHub. You can check it out yourself. The only thing I had to do is I had to go back in time a little bit because we now run Knip in CNN. We don't have any errors that I can show you. So I went back to some time ago where we still had errors. And what we can do here now is we can do pm run Knip, let Knip run on that and report some errors for us. And we can hopefully remove it. Okay, so what we get from Knip is we get 3 unused exports in this file called file cards. Let me just quickly go there. And then we'll see, hopefully, that we have this exported function frontend cards. And you can already see that my editor is also showing them as unused, but there's nothing else that's kind of like, there's no references, but nothing else that does it. So we can just go and safely remove that. And then you can see some more errors coming up because now we have like things that are not exported. And now TypeScript is actually telling us with some things, there's TS6133 that this is not used. So we can go and remove that as well. Then we have the backend cards. Let's remove those. And then there's mobile cards. This is the third one. Let's remove that. Some more things show up. Hey. And then there's generic cards all of a sudden. So that's also unused. So we can remove that. That's cool. Oh, and then more things show up. So, you know, our goal is to get to 0 red stuff over here. So we have quite some work to do. There's a sparkline chart that we apparently no longer need. And some more stuff. Okay, it's like it's a gift that keeps on giving, right? It's more stuff to do. It never stops. Okay. Remove this. More props. Anything else? Yes, there's some more. Function. Okay. This is actually quite fun and oddly satisfying. Whew, more things. How much more can I do? Style components. Ah, hate them. Okay. Some more. Yes. More. Okay. Oof. And now there are like all those imports. I'm just gonna auto clean them up. Wait. Find the right keyword shortcut. Yes. Okay. Cool. So now they're all gone. And now we're down to 0 red things. And that's when, you know, even let me take a look at what the diff is here. We just we went from 565 to 191 lines of code. So I think we just removed like 2/3 of that file because Knip showed us these 3 things that we could remove. Okay, so now we're done, right? So even if we find like this file and we see that these things are unused in our IDE, this is usually where I would personally stop because that's quite something. But you know, we've removed a lot of imports here. So maybe just to be sure, let's run Knip again. Maybe there's some more things we can do. I don't know. Let's see. There's some more things coming up that we can now remove. So there's now, like, remember we had the sparkline chart component? Yeah, turns out this was the last usage of this sparkline thing. So now we can just remove the whole directory. And even better, we can now go to package.json and remove, that's the wrong one. Package.json. We can remove some dependencies because nobody's using these sparklines anymore. So we can remove dependencies, and fewer dependencies in these times. That's a good thing. Don't need to update them anymore. And there's some more unused exports. It's utils. This one's actually quite interesting because we can see there's still one usage left, but this is the only usage in the product. So it's in the same file, which means Knip will still find it for us, but we can't fully remove it. What we can do is we can remove the export in front of it so that it stays local and we can easily clean it up when it becomes completely unused. And then we have another util here, vital card details. Can be fully removed. Then obviously there's some more stuff to remove. There always is. Never stops. And then all those imports again. Let's clean them up. All right. But now we're done. Are we? I don't know. We need to run Knip again to find out. Maybe there's more stuff we can do. Okay, excellent. Knip found no issues. That's the thing we want to see at the end. And then we can make a PR, and then we know we're really done with our cleanup. Okay. So I think removing all of this totally unused code, that was really fun. I really enjoy doing that. It's my favorite part of the job. But maybe we could do some more. We didn't stop here because sometimes developers do this thing called writing tests. I don't know if you're doing that. AI does it a lot for you these days, maybe. So what happens if we have some code that is actually unused in production, but it has a test, right? So if you do static analysis, you will find a usage of it. But technically, it can also be deleted because both the test and the actual thing that we're testing is unused in production. In those cases, we not only have to maintain that code, we also have to waste time in CI to test it. And if that test is flaky, we rerun the CI pipeline like for no reason all the time, and that's like really. So can Knip detect those as well? And the answer is yes, it can, because it has a dedicated production mode. And in its production mode, Knip will focus only on the things that we're actually shipping to production. And to get there, Knip must know what is a production entry and which files in the project are marked for production use. And it has a special syntax for this. It wants us to use an exclamation mark at the end for those things. Now, most of the plugins will know about this and will do this automatically for us. But just to take an example from before, every TSX file in source would now be our production code, and source main TSX is the production entry point. And next to it, we would have some JavaScript code in a build directory, which also has an entry point, but they're not marked for production. So they would be invisible in that production mode. And this obviously works nicely if you have like a new project and everything is nicely structured. In Sentry, it looks more like this because we have to like do a lot of exceptions because mainly we don't really have a structure about where to put our text helpers and fixtures. So we kind of like have to exclude them with the leading exclamation mark from production mode with the trailing exclamation mark. It gets a bit more complicated to set up this configuration, but it's still totally worth it because those are the things that I don't even see in the IDE as being unused because there is a usage, right? And just one example that I have from the code base is that we found the util function called getIncident discover URL that had a test, but it was unused in production. So we could just remove both of these things. And I think setting it up is really worth it because over 2/3 of the dead code that we found actually came from Knip's production mode. So I think that's really worth also, even if it has a bit of more setup to do. Okay, now I think this all sounds great, and we were able to remove a lot of that code with Knip, but this is a real life story, and we have to acknowledge that not everything was perfect, and there were some problems and limitations that we ran into that I would like to talk to you about quickly as well. Now, probably one of the biggest one is that it influences how we work. And Sentry has hundreds of developers contributing regularly to the code base. So any kind of like change in how we work is potentially disruptive for someone. One thing that I've seen that we tend to do is that we add code that is not immediately used in a pull request, but that we need in a future PR maybe. Now, of course, it's not possible for Knip to differentiate this between like really dead code or dead code that we still want to use in the future. And one PR I made for deleting code got closed because it was deleting some code that people were still planning to use. It was just deprioritized in the product, and it was 6-month-old code, but there were still plans to use it, so we had to keep it around. Now, I think with Knip running in CI, coding like this just doesn't work really well. Of course, you can make exceptions and opt out of things by adding some ignore entries to Knip, or you can mark things with the public JS document, JS doc comment, then Knip will leave those alone. But I think it's probably better to just write code that is actually used immediately. I think PRs should be isolated units of work, and we can always hide things behind feature flags if they're not ready to show to customers in production. Because eventually, if you have these public comments or you forget your ignore list to clean it up, this will actually prevent it from being reported when it actually becomes unused, maybe in a year or two. Another thing that I've seen is the tendency that we write export in front of everything. I don't know if this comes from copy-paste or this is just something that we are used to do, or maybe AI just always adds export in front of everything it writes. I've seen that too. But of course, when you do that and you don't really need it outside of your file, Knip will report that in CI, and then you have to go back and fix your code and push it again. And this kind of like creates this slow feedback loop that everybody hates. It's kind of annoying. So to address this, we've created an optional pre-push hook that people can opt into and run it before they're pushing code on their machines if they don't want to wait for CI to finish. Another good news is that Knip has since also shipped a language server, which powers their MCP server and also the editor integrations in VS Code and in IntelliJ. So that means we can now get those red squiggly lines directly in our IDE, which really can help with this otherwise slow feedback loop. And another thing that I found to be tricky is if we are having tests, if we have something exported that we only have exported because we have tests for it. Now, let's go back to the initial example that I had with the file size component and the format bytes function. So if we want to write a test for our format bytes function, we would probably export it and then have a separate test file and import it there and write some tests for it, right? This will work, but in production mode, those test files are invisible to Knip. So it will mark this export as unused in its production mode. Now, I personally think the best thing we can do here is to not test implementation details, but to focus our testing on the public interface that others are using as well in your code. In this case, that would mean writing the test for the function component that is exported and not for the underlying util function. Now, usually half the room disagrees on this because it's kind of like a divisive topic, and it also can be annoying in code bases that kind of like have been around for longer. So what we can tell Knip to basically ignore this with an add internal JS doc comment that's not as invasive as the public comment. It will just mark it as not meant for public consumption. So it's only exported from something as tests, and it will still be just reported regularly in the regular mode, but not be reported in production mode. We did that at first, but then there's another thing I found in Knip, which is the ignore exports used in file setting, which is something that we're now using in production mode. Because with this option enabled, Knip will not report an export if it still has a local usage. So since the format bytes function is used locally in that file size component, it will not be reported in production mode for us, which I think is a good compromise, because in production mode, we actually want to focus on things that are basically unused, completely unused apart from tests. So I think Knip really has a way of dealing even with these annoying Alex situations. Now, apart from influencing how we work, there were also some technical interesting limitations that I think are worth sharing. The first one is about dynamic imports. And dynamic imports generally work well. We were just having one interesting situation in one of our main entry points where Knip just didn't pick up on certain things. We have one case where we trigger a dynamic import promise early, and then we awaited it later conditionally. Now, for performance reasons, Knip wasn't keeping track of where this variable is used, so it reported everything below as unused. And the fix here was just to add this entry bootstrap initialize main to a list of known entry points. But it's also good to know the Knip keeps getting better, and this is no longer an issue. We could since remove that because it has improved over time. This was like a year ago when I made those things. But I also managed to delete some code that I really shouldn't have, because we were doing some very highly dynamic things with require.context. So the more dynamic things you do, the harder it is, obviously, for a static analysis tool to frame things correctly. And require.context is a Webpack-specific feature where you can basically import a whole directory based on a regular expression, and then Webpack will do some build time magic and turn this into dynamic import, I think. Now, in one case, we were loading all of our forms, and some of them were reported by Knip as unused, and I didn't find any usage by looking for usages, and I didn't know about this, so I just deleted it, which was not so good, so we restored those forms later on really quickly. But yeah, the more hugely dynamic things you do, which I'm personally not a big fan of either, you might run into some troublesome situations. Good news is we're at the moment rewriting our form system to 10-stack form, and this will all go away hopefully quite quickly. Okay, so all in all, the whole journey took me about 6 weeks, made over 50 PRs to the Sentry code base, which has about 1 million lines of code, and we were able to remove almost 3% of the whole front-end code base, 28,000 lines of code, thanks to Knip. But the biggest win, I think, is still that Knip now runs in CI and prevents new dead code from being added. Because sometimes when I review a PR, I find like a failing pipeline where Knip reports that something has not been cleaned up that could have also been cleaned up, and then another follow-up commit that says something like make Knip happy, and then more code gets removed. And I think that's really the best benefit of it once you are in that situation. So if you want to try out Knip, it's as easy as running npx knip on your code base. See how far you can get without any configuration. I'm sure it will show you some good findings. And if there are some false positives, go and add some configuration, and then declutter your code base to one Knip at a time. Thank you.
Thank you, Dominik. Any questions? Everyone's hungry.
I don't know where the lunch is. That's a question. So.
Do you have a question?
Hey, thank you. It's really cool. I have a question though. Do you plan to build a auto fixer kind of argument to the Knip CLI so it fixes automatically the simplest removal?
Yeah, there is one. So I think there's an option --fix to just do it automatically. I just like to do it manually because it's fun. I don't know. It's I don't want to outsource the fun parts to like AI or tools. I want to do the boring parts. Yeah, as we've had false positives too, I think it's good to be able to review it like yourself before you're doing it. So I would run it locally if I wanted to. I would not have right now. I would not want a CI job that runs --fix like I format some files automatically. This is a bit different. So yeah, you can if you want. It used to be experimental for some time. It's now safe. I think since version 6. So you can go ahead and let your CI job do it for you as well. All right.
Hi. I'm wondering if you have any experiences on this, like outside of monorepos, like in a multi-repo setup.
Yeah. So, I mean, you would have to, if you have multiple repositories, it works well in Sentry doesn't have a monorepo. We have just like one big everything, big ball of mud kind of situation. But even in a monorepo, it works great because it knows about the boundaries between the actual packages, and you can even find unused things even if one package exports them for other packages. So that's great. If you have multiple repositories and you basically like publish a package and then import the other, you would probably have to like set it up separately for each repository on its own. And then it's obviously not that easy to find. This is some internal thing that's that has a public interface that exports things, and then you don't use them anywhere else. You would have to think about, do you want to keep them because they're a public interface, or are they safe to remove? That definitely gets a lot harder in that situation. I'm a big fan of monorepos because we've had like changes where you had to go through multiple repositories to make changes. We once had our design system in a separate repository. That was awful. So every change was like, we made a change. Oh no, we don't want that change. It doesn't work. We have to go back to make another change. It was, so monorepos are actually really good if you can have them.
Right, thanks.
Last question. Someone else wanted? You're good. Okay. All right. Thank you.
Thank you.
Okay, so you know what's next? Lunchtime. Let's meet back here at 1:30. Lunch is over there. And yeah, I'll see you around. See you in a bit.
Are we back? Yeah, we're back. Hope you all enjoyed your lunch. And how can I tell you? This couch is super comfortable. You can buy it from Sweef, our conference sponsor. Really? Ugh. Okay, I'm gonna be really with all of you. I don't really care if you like the couch, but it's really good. It's really good. But would really like to invite you to visit Sweef's website. It's sweef.se or sweef.no or sweef.de, I think. Whatever works best for you. I'm still waiting for the PT version, but that's my problem. And you can take a look how you can configure your couch because it's amazing. Like the configurator that I did, it is just when you want to buy a new MacBook and you're just configuring the options and then you revisit the next day and it's a pleasant experience. Imagine that before a couch, like all the options they give you. It's really well done. I'm just saying this from a developer perspective. It's really worth visiting. And their website was made by our friends at the Zico Stockholm or ZCO Stockholm. So it's really nice. I can really strongly recommend it. With that said, let's get this show on the road. I'm gonna go back to React now, and next talk will address, the stuff that happens between the user action and the results. Submitting a form, clicking a button, waiting for something to happen. How can we handle those states with suspense, and other stuff like that that you probably know better than I do. So to talk more about that, please a big round of applause for Aurora Scharff.
Thank you. Hello, everybody. Thank you for that introduction. And just making sure everything is good here. Yes. So yeah, I'm so glad to be here. Thank you for having me here. React Norway. This is my first time at this conference, even though I am from Norway, so that's fun. My name is Aurora. I work as a DX engineer at Mittwald on the Next.js team. And I'm going to show you how we can design the in-between states with async React. So I know that agents, we're all coding with agents, but we're going to do some old-fashioned coding today, so it'll be fun. But I do have something for your agents at the end, so stay tuned for that. So let's get started. To learn about this, I have built an app, which I normally do to teach people how to use React specifically. So this is like a conference companion app sort of thing. It's very nicely themed for this pink light, I would say. So this is lets you filter different talks and read about them, but I have a lot of UX problems in this, which we're going to have a look at. So the app feels super broken because when I click around, you'll see there's a very long delay before I get. You can see my clicks there, right? It's like a 2-second. So it's quite broken, and I have this page here, which is just jumping around like crazy. And I have another questions page, which everything just feels super off, right? So what is the cause of this issue? Well, actually, it's not that the interactions are that slow. It's just that the moments between our user action and then the final UI is missing. It hasn't been designed yet. So this is more of a UX problem than a DX problem, which is why we typically forget about it as developers. So to better understand why this is happening, let's look at the React render cycle. So you're probably familiar with this, but in React, we have an event, where the user would click something, which can then schedule where React does an update to figure out what has changed, and then schedule the re-render to re-render the component, and then finally commits that to the DOM. So this is very straightforward when things are asynchronous. Now bring async into this, and suddenly we have a lot of gaps in our render cycle here. Between event and update, we have a busy state, which maybe the user clicks something and nothing's happening yet, right? Between update and render, we might have a loading state. Maybe we're loading data. And then between render and commit is just the state between React having figured out re-rendering the component and then committing that to the DOM. So that's also one of the in-between states we can work on here. Now you might try to handle this yourself with use effect, use state, start handling a lot of race conditions and writing a lot of boilerplate. And this is really hard, and it can lead to lots of intermediate states and weird flickers on your screen, because all of this would be outside of React Render Cycle when you're doing it with use effect yourself. And this has been a classic React problem, unsolved for quite a long time. So to solve this, the React team introduced something called Async React, which is a set of primitives for coordinating asynchronous work in your React applications. And the foundation here is transitions. So a transition can wrap all of these interactions and coordinate them for you. Now, the terminology here is that we're batching together all of this as an action that can then commit to the DOM at the same time once everything is ready. And this will prevent any weird flickers or intermediate states. And for each of these gaps, we have a primitive that we can use to design the in-between states. So for the busy state, we can use optimistic to make some sort of instant feedback to the user depending on what we want to do. For the loading state, we can use suspense to define or design our loading state so that it looks nice for the user. And for the done, we can also optionally add a view transition to animate between those two parts of the UI changing. Now, this is really crucial when the network is slow, because if we don't handle it, we're going to get the experience that you saw in my app, right? But as the networks get faster, then all of this kind of just disappears and it feels like one synchronous operation. So that's really the goal, to design for the cases where the network is slow and we have to look at these loading states, but have them disappear when we don't need them. And async React, the gaps where async React, or we're going to add this, is typically when we do async data loading, async navigation, and async view sequence. So this really works well when the frameworks integrate with all of these primitives and with async React. So I'm going to be using the Next.js app router, and it's all built on top of suspense and transitions. So that will be super easy. And server components also work with suspense. So we're going to have a look at that. So let's go and fix the app, shall we? Oh, great. So let's begin with doing the async data loading. So right now, let me show you. When I reload this page, you'll see there's quite a long delay because I'm actually blocking my page load with my data fetching. And this might happen if you're doing any sort of server-side data fetching, like a loader or server components, which I'm doing. So we need to design this loading state so that it makes the user experience better. And keeping these components over here. So here we have this event grid, which is currently my slow component. And we're going to use suspense. So suspense works with any suspense-enabled data source, which could be server components, or use suspense query if you're using libraries that support that. So let's wrap this with a suspense. And what's really important when we're using any sort of loading state, not just with suspense, but we need to provide a fallback that has the appropriate shape for the content. Otherwise, we're going to get a cumulative layout shift where the UI jumps around. So this one's pretty easy. I already have a nicely sized shape of fallback UI here, which I can import, hopefully. Oops. I mean, should be fine in a second, right? There we go. So by doing that, I can now instantly load the page, and I have this fallback UI for the content. And even though this is the same speed, it feels predictable and it feels faster for the user. So we can actually stream in this server-side fetch data. Now, another thing we can do when we're using async React is we can animate between the loading state and the UI. And that's really simple with view transitions because they integrate with all of this. So I can add a very simple component. This is built on top of the web view transition as a React component, so it's from React. And adding this within a suspense or transition will be able to trigger an animation. So now I have this very simple crossfade here. It's quite subtle. And if we want to customize it, we can do that as well. So let's say I want to make this more impactful, have more design on this. I can add some custom CSS. For example, for this one, I can add a slide up so that the content can slide up once it gets revealed, and do the opposite on the fallback, so it can actually slide down on exit. This is just a pattern that I found in the React docs. I just think it's pretty cool. if I can code today. I was like coding really well earlier. Hold on. Let's see. And we're gonna move this in here. There we go. Okay. So that should give us quite a nice animation. Yeah. So yeah, that's our first in-between state design for this async data loading. We can do another one. Let's go to this session page here. Let's pick one that looks like this. So you'll see I have this weird jump. So even if I'm like trying to pick the target this UI and then it moves around. So this is cumulative layout shift and it's really bad for your web vitals. So we should be avoiding that. On the session page, I have this empty suspense, which is a part of the problem. So I don't have any loading state for this part. That one we can just do the same as we already did. Let's do a UI that has the same shape. And that should get us a little bit further. But still, I have this shift here. And it's like basically unavoidable because I don't know what the shape of my content is right now. And one thing I want to show you, which you can use to debug this, is this new suspense panel in the reactive tools. So this can actually let me step back and forth between my loading sets. So that's really useful if you're trying to debug what is happening in your loading experience. So clearly I have a shift here earlier, right? And if I have a bigger content, it would be shifting more. So this is just something, it can't be the way. It's going to cause layout shift no matter what. And to fix this, what I want to do is actually move this part of the UI that I can't control into the suspense that I know how to control. So that's going to be this one. So if I move this one layer down, let's actually move this here. I should be able to now put everything inside the same and then nest the following. So we don't have any more shift on this comment section. And then we can improve the comments too by just doing a better fallback here. Let's add one here. And we can even animate this. Why not? Let's do an animation with a simple crossfade again. And let's see how that looks now. So now it will be stable, it will be animated, and we don't have any weird flickers anymore. We're going to do one more async data loading improvement here. It's in the questions. So right now it's blocking again, but this should be a quick fix now that we know how to do this. So let me just head over to this page, and I'm just going to switch this question feed with a nice animated loading skeleton supported one. So let's do a small shortcut here and just bring it in, because you already know how to do this now. So there we go. So that's all of the async data loading design. So let's move on to the next one. I mentioned also async navigation. Let's reset for a bit and do that one too. The current places where I have this problem would be in the tabs where I'm actually using search params to do filtering, pretty common in web applications. Same goes for this. Let me move this up here. I'm also filtering with search params. So I'm refetching the data, some sort of slow navigation here. So it is a navigation, even though conceptually I'm on the same page here. So let's have a look at this one first, which is definitely delayed. It's inside of my page. I have a component, home tabs, which is using the search params in the router. And it has this nice pink themed design UI component, bottom nav, which I've been using across my app. So what if this component could just magically fix this for us? What would that look like? Let's try to change this to an action and see what happens. Do you see that? So I didn't really change anything in my code except for this property, and then it's now handling its own async coordination internally. So what is this prop? Why is this working? It's actually not doing anything special. It's nothing with the name. It's just that I'm calling this inside of start transition. So here, we're letting the component, the reusable component, set its own optimistic state internally, and then just track that with transition and make sure we can provide that feedback as per the design. So this is called the action props pattern. You can find it in the React documentation, but it's very underused right now because this is sort of a new thing. So that's why I'm trying to cover that. But this will kind of let us, as the consumer of this component, not worry about any of that. And we can try to do the same thing in our filter up top. Let's find that. It's currently somewhere in my app. I think it's not here. Here. Oh, wait, not there. In the site header. Yeah, that's where I'm keeping this. So it's a label filter, looks very similar. And you might have guessed it, but my design toggle group also has an action prop. So let's see if that would help. And to make sure to name this correctly so that we understand what behavior we're getting, the convention is to call this change action. So let me rename this. And that should be enough. Let's see. There we go. So now I have instant instant feedback on these buttons too. And another thing when we're using transitions is that these are now interruptible. So if I go to the wrong page, I can go back because that's how transitions work. They're going to prioritize your last interaction. All right. So here's the thing with this pattern is that if your UI components, even if it's your own or if it's something like Radix or Base UI, if they can expose action props, we would just use them and it would just work on its own. So this is kind of like the higher level vision from the React team, which we're working on, but yeah, we'll see how it goes. That's the goal because that means we don't have to think about this as users. So that's our async navigation. So I guess we can then, since we no longer have these frozen janky navigations, we can move on to the next thing that I'm going to do. This is more of a bonus, but I want to also show you that you can add page transitions with view transitions. So if I want some sort of sense of space in the app, not just UI switching back and forth, I can slide my pages back and forth, so it feels like I'm in an app. And we can do this also with view transitions. So let's say I want my page to slide from right to left when I click this. So I would be able to add to this page, the section page, a nav forward. And wrap that. And this is a helper that I've made, which just uses the view transition under the hood and gives some custom names so that I can trigger these on demand when I'm navigating. So I'm going to add that there. Same thing for going back. Let's say I want to go back to. Let's do that here. Nav back. It's going to slide the other way. And so I've set that up. But to be able to actually trigger these types of view transitions from my links, I have some techniques. So let's check out the event grid. This is the link somewhere here that I'm using to navigate. And in Next.js, there's already support for a helper here, but you don't have to use the Next.js links, of course. It's just a shortcut, but they have this transition types, which we can add nav forward, like that. And that should be enough to get me a nice slide. Sweet, it's working. And then we can also animate this back button. So this is a different component, and we're going to do the same sort of thing with adding manual transition types. I'm keeping this over here. And the layout, I just have the same sort of tabs, this reusable thing that I built. And I need to call transitions or view transitions inside of transitions, but I already have this action that we were using earlier. So I can just add a transition type to this. And let's say now back. And this is from React. So this is your manual version if you want to do it in a framework that doesn't have this utility. And that should be enough. Let me just double check. So we have a slide back and then a slide forward. So that's working. So this works under the hood with Next.js because the router uses transitions, but again, you can do it manually as well. Let's tackle the last part that we're missing, which is the async mutations. So I have a couple spots where this is now still broken. So this favorite, it's very delayed, right? And then also on especially the questions, I have like a lot of interactions that should feel responsive but don't. For example, this upvote, and also let me just sort by new so you can see it. Let's say I add new. Yeah, so it's quite delayed, right? So this is our next challenge. And we're going to start with the favorite button, the easy one. So let me just find that. This one looks pretty normal. I didn't add any use state. You could have done this yourself with use state, but it's going to be smoother with transitions. But I'm just calling my server update, and then it's revalidating, and then it appears. That's why it's delayed. And we don't have any fancy action props, but we can do it ourselves. So I'm going to do this manually with a use optimistic hook. So ideally, if the framework or your library supports all of this, you don't have to write it yourself. But we're going to do it here. And use optimistic can take in the server value that it's going to call back to when there's no optimistic update happening. And then it can give us a optimistic value and also a setter function. And let's just use this all over our component. And optimistic is coordinated with a transition. As you saw, it's all bound to a transition, and we don't have that right now. So we can add it ourselves with use transition, or we can use the React built-in one that is on a form and just put everything here. So let me press the button. And this is already using a transition under the hood. We know that because of the name. And then we can move our coordinated work into this one and just get rid of the prevent default and just keep the one stop propagation. And that should be enough to give us interactive favorite buttons. Great. And notice if I like click this and then click the favorite, everything is like responding immediately, and it's all in sync, right? Because it's all using async React. We're gonna do this a couple more places, specifically on this questions page. Gonna make this feel a lot better. So that would be here in the questions page. And just close this. So right now we have a question form, which is what I'm submitting to. And I'm going to do something pretty cool. I'm just going to rename this to a optimistic question form. What this is doing is actually, it's a pattern that I learned not long ago, but you can add an empty list, and then this component will just contain whatever is new, and then as it's done, it will settle into the server side list here. So it's using use optimistic, adding a new question, and giving it this pending UI, and using the same question cards. So let's see how this works. So now if I sort again by newest, we should be able to say and get that instantly there. And it just settles into the list as it's done. We're going to also fix this upvote. It's also still slow. You already know the drill by now, but I'm going to add in a upvote here. And let's see if I can remember how my buttons work. This one, so I'm just using use optimistic, and I'm using here the reducer function so that I can correctly increment this and get this all over my component. And then I can call the trigger function inside of my action right here. And I'm going to show you what the result of this is in a second, but let's add some more features first. So one thing we can do is, well, I guess you can see it now, but when these reorder, which they would if I have them filtered in a different way, they just like kind of jump around. You don't really see where they're going. And we can also animate this very easily with React's built-in view transition. So in the question feed, I have a list, and I have this card, which to get this animated, we just have to give it a key, and it will work as long as we're using something that's triggered by transition to create that reordering, which we are. So let's add a view transition with a key and wrap that, and we don't need this key anymore. And one more thing that we can also add here to make this really pop is to handle also changes from other users. So maybe if somebody else is clicking at the same time or they're adding a new question, I'm going to add a very simple version of that. I'm going to add in a poller. And all this is going to do is just refresh the router on an interval and on focus. So it's using the router, which means it can also trigger the animation that we're trying to get here. And let's see if this is going to work. So I have here a couple of users. And now I should be able to say, you know, new question, upvote. Looks nice, right? And it's all, I mean, it's just very few lines of code, but it can really make it feel just super responsive and interactive. And one thing that I get questions sometimes, like right now I'm just using Use Optimistic directly, but if you're gonna do this in your real app, you might want to maybe do a toast if there's an error or that sort of thing as well to make sure you handle whatever might be going wrong from the server, either expectedly or not. Yeah. So this is actually all of our async mutations designed too, and we're handling our data in both directions. I think we're done, but in case you forgot what this looked like in the beginning, let me revert all my code. I always love to do this in case you get scared. Anyway, this is what we had earlier. Let me just restart this here. So it's like, what is this even? Right? Did I even click? I don't even know if I clicked it. How would I know? Yeah, so this is what we started with, right? It's terrible. And then I have put this, I've just deployed this so you can see it again. So yeah, this is what we ended up with, right? Where we have this coordinate animations and it's interactive and it's responsive. And again, the interactions are at the same speed. They just feel way less terrible because we're designing in between states accordingly. And this, of course, increases your web vitals, like for first content with paint and interaction with text paint and cumulative layout shift, which we talked about already. So it's great for performance and for SEO. And it's a pretty small app, but these patterns really scale. So in my case, I'm using server components so that I can avoid the client round trip and then coordinating everything with Async React. So this means that I can build apps that are performant and interactive, and your users are going to thank you for this. Now, finally, I did mention that I had something for your coding agents. So I have actually in my repo here a skill that I made. So if you want to hand this over to your agent, you can try it and see what it's going to do. It's designed so it's going to try to add wherever it thinks is a good place. So let me know how it goes. Yeah, you can teach the view transitions to your agents. And you can find that here. So the demo app and the view transition skill if you would like to try it. And that's it. Thank you, guys. Thank you for having me.
Thank you.
Do we have questions or no?
I don't know. Do we have questions?
You
We
do
have
not hear.
we have one.
Yeah, sure. Let's do it. It's really bright though.
Thank you for your presentation. I was just wondering if the view transition is considered stable.
It's in React. I don't think it's in Canary anymore. It's might be in Canary, but it's not unstable anymore. It used to be unstable, then it got like they removed the unstable flag. But it depends on what framework you're using. In Next.js, they add it as even though it's technically not all the way released yet, but it works. It's just they haven't completed the feature entirely.
Thank you.
More questions? All right. Thank you so much.
Thank you. Thank you.
Okay. I am personally very curious about this next talk, and the reason for it is we've all used Claude, and that's as far as I've come. With Claude, I'm happy with the results that I'm getting. I haven't really bothered to know how else I can automate my job. But this next speaker, he has the promise of doing a lot more with AI, and a lot of it is even without using Cloud APIs, all locally, not even with installation. So I'm not really sure what kind of sorcery this will be about, but yeah, I'm looking forward to it. So please, a big round of applause for Nico Martin. Okay. Um, sorry? Uh-huh. That was expected. I think it already changed. Yeah, it's recognized. Nice. Okay. Hello and welcome to Look Ma No Hands. As you can see, my talk title follows quite a simple structure. I have a catchy main title in the hopes that you would actually show up, and I then have a couple of interesting buzzwords that try to give you a short idea and understanding of about what I am talking about. But it also means that I need to spend the next 20 to 30 minutes explaining those three buzzwords. So first of all, we are going to talk about how we can run machine learning models in the browser. Then we will talk a little bit about AI agents, and last but not least, we will look into multimodality. Now, whenever I think about an AI agent, I think about something like Jarvis, so the AI agent, helper, whatever from Tony Stark in the series Iron Man. So I thought to myself, how hard could it be to build Jarvis myself, but everything happens in the browser? So let's see how that went. Hey Jarvis. There should be audio output. Yeah. Do I have any appointments today?
June 5th, 2026. You have an all-day event for the React Norway conference. Is there anything else I can assist you with?
Okay. In theory, that did work. we got a response from the agent. And all you have seen happens on device. So there are no network requests done to any LLM, to any cloud LLM whatsoever. So let's see how I've built that. But before we do that, quick words about myself. My name is Nico. I am from Switzerland. I am a machine learning engineer at Hugging Face, and I'm also part of the Google Developer Experts program in web technology and also AI and machine learning, which means that I spend a lot of time trying to bridge the gap between the browser and all the interesting stuff that happens in the machine learning and AI world. And at Hugging Face, I work on a library that I use quite a lot to build Jarvis, and that is Transformers.js. In short, Transformers.js tries to bring state-of-the-art machine learning to the web. It was released in 2021 by my colleague Joshua Lochner. He then joined Hugging Face in 2023, so the whole project is now part of Hugging Face. I joined Hugging Face in October 2025, so I am an active maintainer since then. And the whole idea behind the library is that we have basically the inference part of the Transformers Python library. So we take the API of this inference part, but under the hood, we have completely different technology. So we use the Onyx standard and an Onyx runtime to run the inference under the hood. What you need to know to use Transformers.js is basically just this pipeline function. So we can import pipeline from Transformers.js, and then you can create a pipe. Now, a pipe expects a task ID. So in this case, we want to create a sentiment analysis pipe. We can then define a model ID that is usually the model ID from the Hugging Face hub, but you can also use your own service to serve the model, and you have then the ID of the model there. And when this code runs, it will download the whole model from the Hugging Face hub into the browser. So that means that depending on the model, those could be a couple of megabytes, couple of gigabytes. So we can use this progress callback to show the progress, the download progress. And you can also define the device, so where those calculations should run under the hood. You can use WASM, so each
of those neural network calculations runs on the CPU, which is quite slow. Therefore, we recommend to use WebGPU, and WebGPU is a browser API that allows the browser to run GPU operations through JavaScript. You can also define a D type, and that is basically the compression type you want to use for the model. You can use full precision, which would be FP32 or FP16, which means that each of those little numbers inside the neural network need or use 32 or 16-bit to be represented. But you could also use quantized version like Q4, Q8, or even Q1 or Q2, which means you have lower precision numbers. It also means you have smaller downloads, faster inference, but we also have less precise models. But you can just switch the D type and then play around with different versions of the same model. Once you have the type, you can pass any input through the pipe. So in that case, it expects a text because it's sentiment analysis pipe, and it returns an array of labels. So here it is 99.98% sure that this is a positive sentiment. Depending on the task ID, that changes also the expected input and output types. Here it's just text. In other cases, it is audio or whatever you want to do. Okay, pretty simple. 14 lines of code, and you can use machine learning models in the browser. Now, let's talk about AI agents. And in short, an AI agent is just a program that autonomously completes tasks or makes decisions based on data. At the core, an AI agent needs an LLM, and there are quite a lot of LLMs out there. And most of us use LLMs in the upper left corner, so we have the GPTs, Claudes, Geminis, whatever. But they have two problems. First of all, they're closed source, which means they were trained by Google, by OpenAI, by Anthropic, and you can use them through their text interface or through their API, but you're not allowed to use them in your own systems, and you have no insight into the architecture or how they were trained and so on and so forth. But then we also have open weight models, and open weight means that the architecture and the trained weights are actually open source, so you can use them, you can run them in your own systems. And then we have open source models, and open source means in addition to the trained weights and the architecture, also the training process and the training data is also available. The other problem is that those LLMs are quite big, and the size of an LLM is determined by the amount of parameters we have between the neurons. And that means the bigger the model, the more processing power it requires to use the model. So here we're talking about a couple of 100 billion parameters or even a couple of trillion parameters, which is way too much for a consumer hardware. But then we also have, in the open weight category, we have small models. That means models that are smaller than 4 or 10 billion parameters. We have the Gemma family from Google, we have IBM Granite, we have Qwen, we have small LM3 from my colleagues in Hugging Face. So we have a whole bunch of models that are small enough that we can use them in the browser, and they're open weight or open source, so we are allowed to use them in the browser. How can we do that? So we do have this text generation task in Transformers.js. Here I have the Gemma 4 E2B model defined. And what you can see here is I just have an array of messages. I have a system prompt, I have a user prompt, and then I can wait for the pipe to be processed, for the whole output to be generated. So if we look at the example here, I can click generate, and now it will tell me I'm Gemma 4, large language, blah, blah. Now, it is quite fast, so we're talking about 32 tokens per second. And again, that all happens directly in the browser, so there are no network requests made to any server. But it feels quite slow because we need to wait for the full response to be generated. And under the hood, an LLM works in a way that it basically takes your input as the input to the model. It then runs the input through the model, generates a new token, adds the token to your input, and then generates the next token. So we can actually hook into that loop with a streamer. So here I have the text streamer from Transformers.js. I create the streamer, and then I have this callback function, and that will be fired whenever a new token is generated. And if we use the same example as before, but now with streaming, we can see that it feels way faster. We're still talking about maybe 30, 35 tokens per second, but it's super fast because it just adds tokens as they are generated. Okay, so now we have the brain, we have the LLM, but there's one crucial part missing, and that is tool calling. Tool calling is the concept where the LLM can invoke external tools when needed to retrieve information or perform actions beyond its built-in capabilities. So, what are the built-in capabilities of an LLM? It's pretty simple. It can just generate tokens. That's all an LLM can do. An LLM cannot call a function. An LLM cannot do anything. It can just generate new tokens. Now, to see how that works under the hood, we need to look a little bit inside the model. So what we have here is still the same or a similar array of messages as before. But what you have on the right-hand side is the so-called chat template. So each model has a chat template that it was trained on. So what Transformers.js does is it takes the messages array and creates the chat template for that model. So we can see that we have a special token, the BOS, the beginning of sentence token, then we have a couple of turns. And what you can see, the end of the input is basically the start of the turn of, for the model. And the response it gets is, I would love to tell you the weather in Oslo. I did ask for the weather, but the model has no idea about the current weather in Oslo because it was trained maybe a year ago, so it has no real-time information. Now with tool calling, we can see that we can pass an array of tools, an array of functions to the model. And what happens on the right-hand side is that we have the system prompt, but after the system prompt, we have all the tools in one basic line of instructions, and that is all added to my input. Now with that enabled, I now have the same as before, the same example, the same pipeline, but now I ask for the weather in Oslo, and I have this get weather tool enabled. And what it does now is, well, it cannot tell me what's the weather in Oslo, because all it can do is it can generate the tokens. So that's what it generates, just some tool call tokens. On the application side, I can now work with that. So what we have is this array of messages, system prompt, user prompt, but now the model generates this tool call string. My application can now parse this tool calling and execute the tool that is behind this, this section, and it can then return the weather. The weather in Oslo is sunny and 25 degrees, which is not accurate, I think. But what I can do now is I can return the response from the tool call to the conversation, and now the model can actually tell me, yes, the weather in Oslo is sunny and 25 degrees. And that is the so-called agent loop, because that is stuff that happens behind the scenes while the model is generating a response. That's not what I see as a user, but that's just what the conversations that happens between the application and the model behind the scenes. How can I implement those tools? So there are basically two ways. So one thing I could do is I have my application layer, the LLM is the brain, and I can now write tools, and I can add those tools to the system prompt. I have my weather tool, I have my file tool, file access tool, and so on and so forth. But it also means that the tools and the application and the LLMs, they're tightly coupled. It also means that I am responsible for all the tools, but I'm not an expert in weather, I'm not an expert in file system requests, or whatever. So I need to maintain all of that, even I'm not an expert in those things. A better way is to use the model context protocol. And the model context protocol is pretty big, but one part of that is that it can expose tools to an LLM. So what I have to do in my application layer is I have my LLM as the brain, but then I only write this MCP adapter, and I can then use one or more MCP servers. I could use the Open Weather API server, I can use browser APIs as an MCP server, Google Calendar as an MCP server, and in that case, Open Weather API, they're responsible for the server. I only consume the tools that they expose. Okay, let's talk about multimodality. Because right now, what I have is I have text that goes through the LLM, and I have text that comes back. What I wanted to have is something like this. So I have audio that goes in, and I have audio that comes back out. So I need two steps. I need a transcription service. In that case, I'm using Whisper. And I need a speech synthesis service. In that case, I'm using Kokoro. and now I have a complete multimodal conversation pipeline. Both things, the transcription part and the speech synthesis part, I can do with Transformers.js. So I have the automatic speech recognition task where I can create my transcriber. It will accept some audio and it will return the text of the things that I just said. And on the other hand, I can use Kokoro.js, which is just a small abstraction around Transformers.js. So I have the model ID, same options as before, but now with this TTS factory, I have the TTS that generates, that accepts some text. I can use one of the predefined voices, and I will get back the audio. Let's see how that works. Good morning, how are you today?
Good morning. I'm doing very well. Thank you for asking. I'm ready and eager to assist you with whatever you need. How are you doing today? And what can I help you with? Smiling face with smiling eyes.
Okay, that works, but there's one part missing. Because the title of my talk is Look Ma, No Hands, but now I still need to use my hands to activate and then to end the recording. So I have this one thing to solve, and of course, I can do that with another machine learning model. I can use voice activity detection. We don't have a pipeline task yet, so what you see on the left-hand side is how you could use the model and the tensors directly from Transformers.js, but on the right-hand side, you can see that I can activate this service. And what it did is it recorded around 4 seconds of audio. That means there were around 17 little chunks of audio that were processed by the model. And to process one of those 117 chunks, it only takes 1 millisecond to process that. So it's 1 millisecond for chunk goes in and then returns the probability of, yes, there's someone talking, or maybe that's just background noise or silence or whatsoever. And also the model itself is only around 2.2 megabytes in download size. So that's a super small model that only has one job. Is there someone talking, or is it just background noise? Okay, let's add, oh yeah, I also created this little package on NPM. So because it is quite tedious to work with the auto model and the tensors directly, so I created a recorder that you can just install, and then you have the callbacks when speech started, speech ended, recording is done, and so on and so forth. Okay, let's add that to the pipeline. Good morning, how are you today?
Good morning. I'm doing very well. Thank you for asking. I'm ready and eager to assist you with whatever you need. How are you doing today? And what can I help you with? Smiling face with smiling eyes.
Can you tell me who trained you?
I am Gemma 4, a large language model developed by Google DeepMind.
Okay, so now I can basically have multi-turn conversations without having to manually activate the recorder because the application knows when I'm talking and when I'm finished, so it can start the whole transcribing LLM and so on process. Okay, let's get back to Jarvis. So what we can see now is we have the chat history. So as you can see, we have my system prompt where I tell it how it should behave, the voice should be, communication style, the instructions. I also have the tools it has available right now. Then I have my first request, hey Jarvis. I have the response that we were not able to hear, but it was generated, it is there. Then I have my question, and that's a question it cannot answer out of the box, so it has to call the get calendar entries tool with the date of today. That is the response it got from the tool call. That is the response that it then generated, that it returned to me, and so on and so forth. So what you can also see is we have the MCP settings. So I do have a couple of MCP servers. Some are living in the browser with just JavaScript APIs because MCP is just a standard that sends text from A to B, and it's just a standard way to send the text. Yeah, the payload is basically the standard, not the transfer method. And then I am just also able to solve one of AI's biggest problems because AI is just not funny, but there is a jokes API that returns jokes based on categories. So I create a little MCP server for that. And I can then ask, hey, could you tell me a joke about programming?
Here is a joke for you. What do you call a developer who does not comment code? A developer. Do you require any further assistance?
I see. Could you explain the joke to me?
The joke relies on a play on words. It suggests that a developer who fails to add comments to their code is simply referred to by their profession, a developer. It is a light-hearted observation about the nature of coding practices. Is there anything else I can clarify or assist you with?
Okay. So it's actually able to first call the tool and then use the information that it got from the tool. Let's take the last couple of minutes to open up another box of things, and that is vision language models. Because right now I have multimodality with just text in, text out. But what if we could also use images? What if it could also see what's happening in the world? What we have with vision language models is that we have images and we do have text. The problem is that text and image, they're not the same data type, they're not the same things. The good thing is that an LLM or any machine learning model can either look at images or it can read text. All it sees is numbers. So what we need is a tokenizer on one side. So each LLM comes with a tokenizer that takes the text, splits it into tokens, takes the token IDs, creates embeddings of those IDs. And on the other side, we have a vision encoder that takes an image and encodes it into the same multimodal context window. So we basically now have a shared vector space where images and text can basically live together in the same place when they mean the same thing in the end. So with this new shared vector space, we could basically train a new model, and with we, I'm not talking about myself, but there are some smart people at companies, also at Hugging Face, that were able to train a model with both token types. And now it can generate new text based on the image and the text. So what I'm using here is the small VLM, which is a pretty small vision language model that runs in the browser with Transformers.js. Here as well, we don't have a pipeline task yet, but we are working on that to have multimodal inputs in the in Transformers.js natively. But what we can do is we can basically create this little demo here. So I can now choose a file, and I can ask what is on the picture. Thinks for a moment, and it says that there is a building on the left side. Okay, building is a little bit of an understatement because it is pretty well-known building, but we can also ask something more specific because it's not just summarizing the image, but it actually looks at the image. So we can, for example, ask what's the color of the bus? And it should now tell me that the bus is red. So we have this little bus down there, which is a normal red London bus. So it can actually look at the image and it sees that there is a red bus. Okay, let's add that to Jarvis. Hey, could you tell me the color of the shirt I'm wearing right now?
The image analysis indicates that you are currently wearing a gray shirt. Do you require any further information or assistance?
Okay, not bad. I mean, it's the query. Camera, there's of the device, and it can then generate a new response based on the image and my question. Okay, that works. So to sum it all up, I have three important key takeaways. First of all, the browser can do way more than you think. Because I mean, I'm a front-end developer. I have worked as a front-end developer for all my life, and mostly as a front-end developer, we are just building cool, beautiful UIs. And that's not wrong. That's nice. It's great to build beautiful UIs, but the browser can do so much more than just displaying documents. We do have all the browser APIs. We do have CSS. We have JavaScript. We have HTML, and now we also have machine learning. So we have all those things that we can put together in the browser. Second, you don't always have to use the biggest model. So when I use AI as a coding agent, I like to use the smartest, the biggest, the latest models because they need to be really, really smart to figure out what I have done wrong in my code and to make sense of all of that. But if you're talking about an agentic setup where I can control what tools are in that setup, we can actually use smaller models. Those can be on device, as I've showed here, but they could also live in some kind of cloud, but they are just cheaper to run. So we don't always use the biggest model. And that is not only my opinion. There's also quite a good article by NVIDIA where they're talking about how we can actually use smaller models where each model is kind of an expert in its own domain to do the same tasks that you would normally do with just those big models that can do everything but are quite expensive to run. And lastly, just try it out. I did not started coding because I had to. I started coding because I was young and I just wanted to see what is possible in the browser. And I stuck with it because I just had a lot of fun building cool stuff. And now we have the whole browser toolbox. We do have machine learning, but it's just a new tool in that toolbox, and we can just use it to have fun building cool stuff. Okay, that was it from my side. If you want to know more about transformer stress or also about machine learning in general, we are publishing more video content in the next weeks on the Hugging Face channel or in the Hugging Face account, in the transformer stress channel of the Hugging Face account, and also on my Instagram channel. So if you want to know more about what happens behind the scenes in transformer stress, please check out that. And yeah, my slides are there behind the QR code. If you have any questions, I think we do have a couple of minutes to answer them. And thank you so much for being here. It was a great year. Thank you.
That was awesome. Thank you. Any questions? I suppose we'll see some questions. I have a question. I mean, in this economy, how much memory do you need to
I will
run
be here
Jarvis?
for the rest of the day, so if you have any questions, I love to talk about
But
it.
how much memory do you need to run Jarvis?
I think we don't have any. No. It depends. I haven't measured how much memory I need for Jarvis, but of course, the bigger the model, the more memory you need. And if you're talking about LLMs, then we are talking about a couple of gigabytes that we need to, first of all, download, and then we need a couple of gigabytes to run the models. I also had a couple of, I have a vision language model and an LLM that both are basically in memory. They're both generating tokens. They both have a KB cache that needs to be stored somewhere. So yes, you need hardware that can actually process all of that. But if we're talking about smaller models, like just the voice activity detection part, there it does not make sense to run such a model on the server in the cloud, because then you always have to send those 32 milliseconds of audio to the server, process it there, and then send it back. So we are way more than just 1 millisecond. So it always depends on the task. If you have small tasks, it doesn't make sense to use them on device, and that gets in the browser. If you have big things like an LLM, maybe it makes more sense to run them in the cloud.
Thank you. Anyone? Well, you have a question. Yeah.
I'm really sorry. I thought your shirt was blue and not gray. Weird question.
It is blue. It is gray.
It is gray. It's gray. Okay, then it's my eyes. Okay.
Maybe it's just because
Maybe it's
the light is blue.
Thank you so much.
Okay, thank you.
How are we feeling? Good? Bad? Good? Good? Y'all need coffee. Yeah, people are like, yeah. Very well then. You shot coffee. Me too. Let's meet again in 30 minutes. and thank our sponsor for allowing us to make this happen. So, random order 5, 7, 12. No mono listen, but you can see how for um, so this is a little thing a few months ago where we offered a free ticket for anyone that wanted to participate. So essentially, go over it and potentially win a ticket. We expected most of the participations to be with electric guitar. However, I'm gonna show you now who won, and it was not a guitar. So this was called Longfall. Hopefully the audio would work, and the internet will work. Hopefully. Yeah, there you go. Where are you, Carl? Where's Carl? Carl is very A minor, which if you don't know anything about music, is only using the white keys on the piano, which means that anyone could have won just by randomly pressing the white keys on the piano, and maybe it could have sounded better. Who knows, right? So congratulations, Carl. Nice to see you. He is a former speaker at a Norway as well, so absolutely. So, final stretch. We're gonna stay on topic. We're gonna talk about our AI. This time around, we will talk about, all the problems we have. We use LLMs and then forget the things we were talking the day before, and they just kind of they lose all the context. So the next speaker is gonna talk about um, uh, programming language actually that will help us with that and keep the context throughout our workflows. So please welcome Robert Balicki.
Thank you. I got it. All right, that is a tough act to follow. There's no music in mine. So, all right, let's see if it connects correctly. Yeah, okay. That's a lot less trouble than it was 5 minutes ago, so I'm quite relieved. All right. Hi, folks. My name is Robert. For the last several months, I've spent my free time working on a programming language specifically designed to make orchestrating agents easy and ergonomic, so you can get the most value and reliability out of your agents. That language is called Barnum, and I hope by the end of this talk to convince you that you should give it a try. But first, let's spend a bit of time talking about LLMs. LLMs are these incredibly powerful tools, and we use them for all sorts of things, whether it's writing React components, or finding the right invocation of a bash command, or translating bullet points into eloquently written Slack updates, or translating Slack updates into bullet points that we can consume. But anybody who's used them extensively quickly becomes intimately familiar with their limitations. They do the wrong thing, they cut corners, when their context gets full, they get forgetful, and you can't just rely on them to consistently do complicated tasks exactly right every time. So good luck relying on them for mission critical things. Honestly, that reminds me of myself a little bit. I get it. And our ability to build valuable abstractions on LLMs is limited by their unreliability. So let's talk about two things that we can do to improve their reliability. First, we can take away their decisions. Consider asking an LLM to write you a daily summary. Oh, this is very small text of all the work you need to do on a given day. Well, it's going to look at all the available tools. It's going to decide which ones to call. It's going to decide how to synthesize that data. It's going to decide how much time to spend researching and going down each rabbit hole. And it's going to decide what format to use when presenting that data to you at the very end. And the next day, it's going to go through that process again. Now, not only is that extremely wasteful, but does anybody think that you'll get consistent results from day to day? Ah. Does anybody think that that's reliable enough for business critical applications? No, absolutely not. The LLM will do something different every time. The best we can hope for is that it's roughly directionally consistent. And yet, that is how most people use LLMs. They leave the LLM in charge of important control flow decisions. And as long as the LLM is in charge, the outcome will be variable. So, first point, we have to take away important decisions from LLMs. And secondly, and quite relatedly, we need to use the tools of computer science to improve the reliability of those LLM calls. Okay, tools of computer science, it's a bit of retries, error handling, basics like that. Let's consider a simple task, like implementing a small well-scoped feature. If it's simple enough, you could just ask the agent to one-shot it. But for anything else, even remotely complex, or whose implementation you have opinions on, that's not going to work. The agent will implement something incorrectly, and the more you go back and forth, the more cruft forms, and the worse the final outcome tends to be. Okay, so everybody knows that you should be using plan mode. That helps. You can iterate cheaply and only start implementing when you're sure that the agent will actually do the right thing. But of course, the agent finds creative ways to fail nonetheless. It builds the wrong thing. It disables unit tests. It gets frustrated and gives up. And Ralph loops or /goal, they help. It's harder for LLMs to give up, for sure, but it can still produce the wrong code. It can still disable unit tests and so on. What we really want to do is ensure that the LLM just does a good job. So what do we do in that situation? What would an ideal workflow look like for implementing something? Well, of course, we need to ask the agent to implement the feature. Then we want one or more agents to review the code for quality, security, adherence to the original task, whether the agent cut corners, whether any of the new functions it created exist somewhere else in the code base, and so on. We don't want the original agent doing that because that's sort of like self-dealing. It's more incentivized to say, yeah, I wrote this. It's kind of amazing. And then we want to write unit tests. We want to run type checking, lint rules, and so on, all the automated checks. Now, the era of subsidized tokens is rapidly coming to an end, so unless we have deep pockets, we really don't want an agent doing all that. Then we want to take that feedback, have an agent incorporate it, and loop until everything is green. Then we want to take that final commit, split it into other smaller atomic commits that can ship independently. And of course, we want to ensure that each commit passes all these tests on its own. And, well, each step might fail, so we use those computer science things like retries and error handling and timeouts. And maybe you want to limit the number of retries to 3 because if you're trying more than 3 times, the system is probably down, so you're just burning tokens if you keep looping. Yikes. Look, I think we can all acknowledge that this is just too much. This is too much complexity. It's overkill. And that there are simply diminishing returns here. I'm exhausted even listing all these. And I haven't even begun talking about advanced things like adversarial review or what have you. No, just kidding. This is exhaustive only because it's written in English. English is an absolutely horrible way to transmit precise technical information. And yet somehow we've collectively decided that we're going to use English to build this brave new world. A Ralph loop, plan mode, they require English. And that's the problem. Or your language of choice, prose, really. If only we have a tool for expressing work that proceeds in a nonlinear fashion. It might branch, it might loop, it might have names for certain subsections of work, it might return early. What if we used a programming language? Well, I won't belabor the point. Programming languages are great. They make it easy to precisely express these kind of complicated workflows. And a more complicated workflow with loops and retries and timeouts is one where we increase our likelihood of getting the correct final result. But I will point out 2 additional benefits here. A world where we're using a programming language for orchestrating agents is a world where that agent is not in charge. If we directly invoke an agent to say, do X and on success do Y, it may or may not follow these instructions. It may weasel its way out when the going gets tough. But if we write a program to that effect, the LLM can't opt out of that logic. Programs are deterministic and repeatable. And secondly, they're also more easily analyzable and more composable. If I tell the agent, you should retry this thing 3 times. Well, it's a little bit hard to like look through a long essay and determine whether I did that correctly. Furthermore, it's hard to look at that essay and say, hey, did every single time I invoke this another subagent, is it wrapped in retries? It's hard to reason about it on that level. Now, at this point in time in the conversation, I take off my mask. I reveal that I'm secretly a member of the technical staff at Anthropic, and I start telling you about all the advantages of dynamic workflows. But alas, I'm not. That's not how this presentation will go. Now, dynamic workflows, which came out this week, are Anthropic's new way of orchestrating agents and code instead of in English. Rather than letting an agent decide its own next steps, you write a normal TypeScript script, or rather, you have Claude for you, and that script calls the model only where it's actually needed. So you can use regular loops, conditionals, retries, whatever, and you get the predictability of a real program while still leaning on the model where it's necessary. For example, to implement a refactor or analyze some file or something like that. Now, I think dynamic workflows are amazing. They're vastly superior to using English to specify precise technical things. But I also think that Anthropic has made some interesting technical choices in workflows with which I disagree. That's not to say version 2 won't be better. I hope it is, but there are limitations in my opinion, and they shed light on why I think you should be considering Barnum instead. Now, while preparing for this presentation, I asked Claude to implement a real refactor that I'm driving at work, basically to go from one API to another, and to implement that as a workflow. Furthermore, I asked it to make it production ready, make no mistakes, all the usual things you say. And what did it produce? Well, it actually produced some pretty impressive code. It's a program with several phases. First, it discovers all the usages of the old API. Then it finds all the top-level call sites of the old API, and then it refactors each tree, passing the new data down as it goes. So let's list the strengths. Well, the transition between each of these phases is strongly typed with the JSON schema, and there's validation. It does a decent job of parallelism in that the main bottleneck, which is to say refactoring the individual subtrees, is parallelized. And the framework handles retries and parallelism and limits parallelism to the number of cores that you have -1. So it just sort of works out of the box. All in all, quite solid. Now, let's take a quick detour and talk about durability. If we're migrating 1,000 files and workflow dies on the 1,000th file, you shouldn't have to redo the first 999. That's very reasonable. It's very admirable. And the way dynamic workflows pull this off is through what I call the temporal model. So temporal, not like the new Node API, new JavaScript API, but like the framework for durable execution. They treat the entire script as one unit of durability. To resume, it reruns from the top. So the first time through, every call to every agent is journaled, which is to say it's written into some sort of external data store. And on every run after that, those calls don't call the agent. They just return the recorded answer instead of calling the agent again. You replay the journal and skip the work that's already done. But this choice has consequences. Well, on the one hand, there's advantages to it. You can just write JavaScript. It looks great. It looks, it's comfortable. It's appealing. It's easy to adopt. But first, the JavaScript has to be deterministic. Now, replay only works if rerunning the script does the same thing twice. So you can't call new date. You can't call math.random. And before your script runs, the sandbox mucks with the JavaScript environment and takes those globals away. It either removes the global or it removes the function on the global object and so on and so forth. Now, I don't know about you, but when I hear that the pitch is this JavaScript code has to be a pure function with no side effects or the whole thing falls apart, and we're going to modify JavaScript globals to enforce this, my alarm bells go off. I mean, it's admirable to try, but JavaScript is the wrong language for this kind of endeavor. Second, the JavaScript can't touch the outside world. If we're going to rerun the script, it can't have side effects. So the workflow script gets no access to the file system or to the shell. Every read and every command has to go through an agent. Now, what if we're driving a refactor in a large code base? Well, one of the things I want to do is list all of the files in my repository. Okay, so that means I have to ask an agent to list every single file in my repository. You're at a big company, that's maybe tens of thousands, hundreds of thousands, millions of files being stuffed into some context for which you're paying, only to have it be serialized into JSON and sent back out. And guess what? Agents are great, they're improving every day, but serializing a list that's 100,000 items long, like it might make a few mistakes. And people say that workflows are code hogs. That's the reason. It just makes a lot more sense to do that work directly in the JavaScript. Just have the JavaScript invoke rep or invoke find. It just makes more sense. And third, you can't use libraries. This is what I think rules it out for real work. The number one thing that we want to do is use computer science to make our workflows more reliable. But the first tool is libraries. Without libraries, the whole thing falls apart. But the sandbox took away the globals that basically every NPM package assumes are there. So are you using some sort of external package that reads some sort of config? It's not going to work. Do you know that it does that? Well, it's JavaScript, so you don't actually know that. Do you know that it's not going to start doing that in some patch update? And now your workflow is going to start failing in some weird edge case? I mean, hopefully it starts failing right off the bat. But one, the workflow could be called rarely, and two, it could be failing some edge case. Like, that's not ideal. It's just normal for libraries to rely on map.random in their algorithms. And now we can't. Fourth, every replay reruns all of your JavaScript. The journal remembers all the agent calls, but it does not remember what your script did in between. So if an agent hands you a big array and you sort it, on every replay, you have to resort that array. Now, to be fair, durability is the right goal. You should not redo 999 files just because the 1000th broke. I'm not arguing against that. I'm saying that full script replay is not the only way to get there. There's another way. Okay, so finally, let's talk about Barnum. Barnum is a programming language for working with asynchronous and parallel computation. And what's the number one example right now of asynchronous computation? Invoking LLMs. So the goal of Barnum is to make it easy for you to orchestrate your agents. And as a programming language, it has three goals. First, it should make it easy to manage long-running parallel tasks. And if it does that well, it makes it easy to manage LLMs. Second, it should be high level and focused on control flow while leaving the nitty-gritty details to an existing programming language, such as JavaScript. Third, it should be easy for agents to write. I think that if we nail these three things, we'll have built a tool that allows you to constrain agents and get more value and reliability out of them. Of course, there's plenty of work remaining to do, but I've already used this to ship hundreds of PRs without breaking production, and I've used this to babysit PRs, rebase them until they're green and they can land and so on. Folks at other companies have used this to build a RAG pipeline, to validate, to find and validate all the claims in publicly facing documentation, to burn through backlogs and implement refactors, and so much more. So with Barnum, you define a workflow, which is a pipeline of how data flows. This is written as an embedded DSL in TypeScript. This gets turned into an abstract syntax tree, which gets serialized and sent to a virtual machine that runs in Rust, which executes the program. That's it. Notice that what I said has nothing to do with LLMs. LLMs are but one example of a long-running independent task. And so if it makes it easy to manage long-running independent tasks in parallel, well, then it makes it easy to manage LLMs. Now, in this pipeline, leaf nodes are just invocations of JavaScript functions that run in their own process. In the future, this will include invocations of functions exported from other environments too. There's no structural reason for this to be JavaScript, to be limited to just JavaScript. In fact, an earlier version of Barnum had that. I did a big refactor and haven't added it back yet. Okay, so let's take a look at an example pipeline that does two things. It analyzes files and generates refactors and writes them to a queue. That's that extraction consumer. And then it reads from that queue and implements these refactors in creating PRs. That's that implementation consumer. In this invocation, we start one of each in parallel and run them in parallel. Now, inside of the implementation consumer, we, as you might guess, implement the refactor and then run all the checks and loop until it's green. So that kind of looks like this. Don't worry about reading the code, just if you're curious about it. If you've written Clojure or Elixir or RxJS, the shape here might be familiar. you're describing how data flows through a pipeline. You don't actually ever get access to the data itself, at least not in that JavaScript. So how do we actually call an LLM in this world? Well, to do that, we use handlers. Handlers are just isolated bits of JavaScript that run in their own process that can do anything. But if they run their own process, they can't access global state and muck with the invocation of other stuff, so they're isolated. And hey, one benefit of this, of being able to do whatever we want, is that we can do whatever we want. So that means our LLM calls don't automatically need to inherit their permissions of the parent. Here, notice that we specified the allowed tools that this invocation of the agent is allowed to do. It's allowed to read and it's allowed to write to one specific file. And we can save a tool call. We actually inlined the refactored or the source file into this thing. In this way, by being a little bit smarter, we can be more efficient and more precise about what our agents are actually able to do. And also, this increases the likelihood that the agent actually ends up doing the right thing. Now, I'm not showing you all these examples to drown you in code. In fact, it might be hard to read, but that's simply because Barnum, in some ways, is lower level than what dynamic workflows give you. We're in charge of more decisions. We wrote the control flow. The LM doesn't decide whether to retry, whether to loop, or what to do when something fails. We decided when we wrote the program. We said 3 retries, not keep trying indefinitely until something succeeds. And if we wanted to cap the agent at 5 minutes, that's also easy as well. We laid out the loop, implement, run the checks, and if it fails, fix it and go again. And with us choosing exactly what to feed into the next pass. Now, think about doing this with dynamic workflows on its own. You sort of have to use the API that Claude gives you. And they retry the agent until it works. That's fine, until the agent does something with side effects. Most of the time, if you're invoking an agent, it's to have side effects. Say the agent runs git stash pop, but it's partway through. So the framework automatically retries. Great, now we're popping the next item off the queue. Ugh, that's kind of a tough situation to extricate yourself from. Retrying only works when the operation is idempotent, but agent operations almost never are. They write files, they push branches, they change the world. Now, when we write the retry ourselves around a handler that we wrote, well, we know what rerunning it means, and we can choose. This one is safe to retry. This one, we might want to kill the pipeline if it fails. Now, you might be asking yourself, is it worth it? Is it worth learning a new language or a DSL and learning new semantics in order to orchestrate agents well? Obviously, I'm biased, but I think so. There's a bunch of advantages that Barnum gets from not being, quote, just JavaScript. First, the control flow and error handling is very easy to reason about. One thing that's always irked me about JavaScript is catches, this magic keyword, and you don't know what errors you are actually handling when you write catch. But with Barnum, catch isn't anything special, it's just a value. The try-catch combinator gives you a catch function, and when that function is invoked, the handler is called. So there's zero ambiguity about which errors are handled by which error handler. Second, it's annoying in JavaScript. It's work to write code in a way that's maximally non-blocking. And if you recall from the dynamic workflows example, we completely finished phase 1 and only then started working on phase 2. And only then, once we finished that, started working on phase 3. That's just not going to cut it for anything that's performance sensitive and more complicated. You really want maximal parallelism by default. And that's what Barnum semantics gives you, and that's just hard to do in JavaScript. And furthermore, we have validation on every boundary for free, or just built into the framework. And because we have so many small handlers, this actually means that we can catch errors and invalid data basically as soon as it occurs, because every handler is very precise about what it can expect and what it can return. And lastly, every handler runs in its own subprocess. There's no spooky action at distance. There's no global state creeping into anything. And it also means that there's no reason that handler has to be written in JavaScript. If you want to invoke some Python library that does machine learning, by all means, it's easy to do that with Barnum. Now, again, this worked in an earlier version of Barnum. It's been removed. It'll come back. Now, a few slides back, I said that Anthropic gets durability by replaying the whole script. I said there was another way to get durability. This is it. In Barnum, each leaf node runs in its own isolated process. And that means that we can instrument everything going in and everything going out. It means that the engine knows all the relevant state. So you die on the 1000th file, come back. The engine already has the state from the first 999 invocations, and it can just keep going. The point is, instead of the entire script being a unit of durability, we know many tiny checkpoints, and we can just resume where we left off. And look at what this gives you. Because the AST is created exactly once, we don't really have to worry about re-executing it. It's just a data structure. Instead, we have this data structure that we can work with, that we can analyze, that we can examine. And all the non-determinism, the file system access and so on, that lives in handlers. And since they're cleanly separated from the AST, they can do whatever they want. Now, of course, there's a cost to this. It doesn't look like JavaScript. It's a little bit weird to wrap your head around sometimes. But Claude should be writing this for you. So hopefully that's not that big of a deal. Now, I'd also point out that I'm a one-man band. Barnum doesn't have durability in the current release, but slated for the next one, so hold on tight. Hopefully by the time this video gets published online, it will have been released, fingers crossed. And just for a concrete example of what Barnum lets you build that's really tough with dynamic workflows is this. Let's go back to that first snippet, an extraction consumer and an implementation consumer running in parallel. The extractor walks the code base, finds refactors worth doing, and writes them to a queue. And while the implementer reads from that queue, does each refactor, runs the checks, loops, whatever, and opens a PR. One side fills the queue, one side drains it. And in our case, the queue of files is just a directory. I mean, that's why I haven't actually implemented durability, is because I'm just using the file system to implement this. When I restart this, the queue continues to be there, and it can just keep running. So I'm running something, it just generates me PR, I review them, I land them, and refact the code over time just cleans itself up. It's actually quite amazing. And on the replay model, you really can't do this, at least not easily, because there's no file system. Your queue would have to be threaded through agent calls. So you're paying a language model to act as an agent broker, a message broker. That's kind of weird, right? And on replay, you have to replay all the messages, maybe like 500 of them in a row, or just like, hey, there's nothing to do. It's just kind of weird when you replay. It doesn't make sense to me. It's not intuitively the right architecture. But for us, it's a directory because our handlers are allowed to touch the disk. So let's put these two side by side. The same goal on both sides: durability, type transitions, parallelism, retries. The difference is where the work lives. Anthropic puts your orchestration in a sandbox and replays it. Barnum hands a description connection and runs your code once. And everything we just went through, that's all downstream of that one difference. All right, so to sum up, the pitch for Barnum fits in a few sentences. Take the important decisions away from the LM, write them down in a real program. One with loops, retries, timeouts, and run your own code in a file system in real libraries. Then invoke LMs where they're needed to implement refactors, analyze text, whatever. But do it sparingly because LMs are expensive and unreliable. And if you do this, you can get a lot more overall reliability and overall performance out of your invocations of agents. Now, my ask of you is this. One, scan this QR code, give Barnum a try, install it, clone a demo, change one handler, and watch it run. Don't start with something complicated. Just maybe iterate over all the files in a folder and run some agents on them. Or even better, don't write it yourself. Just ask Claude to do it. The Barnum has a page filled with best practices, and it ships with a few ESLint rules that make it hard for Claude to mess up. And besides that, star the repository, join the Discord, and let me know all the cool things that you build with it. Thank you.
Thank you, Robert. Cool. Any questions? No questions, and we don't have a lot of time, so thank you so much. Of course.
do this. Get in here with me, Pedro. All right. All right, everyone smile. Wait, I'm really bad at this. Sorry. Jeez. Okay.
Cool. Okay, one more to go. Just some important information after this one, the last one. I want to ask you to go upstairs for the rooftop barbecue because they will be planning it. Yes, because they will be planning a concert for later. And at 7, that's when the concert starts. Just FYI. So before we move on to the last one, I just want to ask you, raise your hand if you think AI will take our jobs. Lol. Really? I don't know. There's one over there. I don't know. I don't know. Like when this whole thing started, initially I thought there's no way. And then a new model comes out and I'm like, it's over. And then a new CVE comes out and I'm like, we're so back. And then Anthropic releases a new model and I'm like, it's never been so over. So I don't know. All I can say about the next talk is that I saw a preview of what we're going to see. And it's over. You'll see. Well, the next speaker needs no introduction. He's a multiple-time speaker at React Norway, 2-time MC at React Norway as well. So please, a big round of applause for Sébastien Morel.
Hello, everyone. It's working. Hello. Really glad to be back on stage here. I didn't lose my accent, though, so it's still going to be a little bit of French. All right. So here you go. Let's wait 10 seconds. Here you go. All right. So let's do this. I'm the last one. I hope I'm going to keep it dynamic. And then it's going to be the concert. So I have a confession to make. I really don't believe that chatbots are the way to render what the AI is giving us back, right? I don't think this is the ultimate output. Yes, we can, and the LLM can actually generate HTML, static stuff, artifacts, and your coding agent, they can generate code, right? But as soon as you have live interaction with the LLM, it ends up being a chat bot, right? So you have a text area, this is the input, and the output are words, maybe artifacts that are static HTML. So this is nice, but this is not dynamic at all, right? What if the model, what if the LLM could actually stream React components directly in your app? That would be awesome, right? But for that to be great and really awesome, those would need to be React components that are full-fledged, deep integrated into your app, right? What I mean by that is those components that are streamed in, they should have data binding, validation, all the cool stuff that Aurora showed earlier, right? You want to be optimistic, you want to have interactivity and action built into those components, even though they are streamed. Another thing that you want, if you let the LLM stream component, is you want to have control on what you are going to render, right? I mean, you are not going to be rendering them. The AI is going to do it. So you need to be able to have some constraints on the theme, on the colors, and stuff like that. So there will be a world where the LLM is generated the full UI or a part of the UI. So I'm Sébastien Morel, and I'm CTO at Crystallize, and I'm going to share the journey that I did to try to see if it was possible to do that. So we're going to do it in 2 steps, kind of. So we're going to bring the AI into your project, streaming component, and we're also going to flip it around and bring your project inside the AI, like Claude, for instance. For that, we're going to use some kind of cool tech. So let's do it. So no more slides for now. So for the back end, I'm working at Crystallize, so I'm going to talk a little bit about it. 1 minute. backend as a service. This is where we are going to fetch the data, the images, the content, the pricing, the asset. This is where we're going to use that to create the cart, the pricing. Again, we can have promotion. I'm just showing up a little bit of interface here. And what is important though is if we want to work with LLM, we're going to have an agent. We need an MCP server in order for this agent to actually not hallucinate. So we want it to be able to fetch the data from whatever storage you have. In this talk, we're going to use Crystallize, of course. Who have used Crystallize, by the way, here? It's true, we can't see. Okay, nice, good. You should check it out. In terms of runtime, because Crystallize, we are in e-commerce industry, so we're going to use Bun because milliseconds matters. So that's going to be the runtime. We're going to use Next.js because again, milliseconds matter. So you've seen before how quick and nice you can do the UI using Next.js. And another one that I would love to see if you have used is the Vercel AI SDK. So who used that library yet? Okay, just a few of you. Cool. Usually when you want to talk to an LLM, whether it's Anthropic or Gemini or whatever, you would actually install the SDK of this specific company, right? The Anthropic SDK or ChatGPT, I mean OpenAI SDK. But Vercel, they've done some kind of cool library where they have abstracted away all those providers. So you use Vercel AI SDK and you can switch the model whenever you want, right? You're not happy with OpenAI anymore, you go with Anthropic, or you want to be compliant for the European regulation, you want to use AWS Bedrock, you just switch the provider and your code doesn't change, right? So if you didn't check this out, it's kind of awesome. And the other thing that is awesome is streaming. We've seen Nico showed that before. This library will enable the streaming as well, and not just the streaming of text, but also streaming of JSON objects. So you can tell your LLM, return me this JSON structure only, and you have streaming of that. So which is smart. And last but not the least, Vercel again. They have just released this library called JSON render. And that's going to be the key of what we're going to use because this library will allow you to get some JSON in, and this JSON is going to turn into a React component that we're going to stream. So this is what we're going to use together. So in order to show you that, I built a little web shop, right? So very simple web shop. You have a catalog, you can click on product, you can add to cart, and you have a cart. Cool. But to show you a little bit more the streaming of components, we're going to use a very simple page that you can build at build time. And I did that. So this is the lab, and the lab is just to show you how we can generate a page completely letting the LLM building the UI. So first we need constraint, like as we said before. So I'm going to show you the code, but I have constrained this LLM to use only my design system. So this is the available component that the LLM will be able to use. And then we just have to give it a prompt, right? So if I go there, I have different persona. For instance, accessibility, we talked about it a little bit. So this is a persona that, okay, I have disability, blah, blah, blah. And I asked, my next project to ask the agent to generate a page. I click on the button, and this stuff, I don't even know what it was before, right? It has been generated by the LLM automatically. You're going to say, whoa, too fast. It's too fast because it has been cached. I'm going to show you a real example live of the same example. So I built a React Rocker persona, which is you, and I'm going to ask it to generate the same page, which is music stuff, show music title, promote a single bestseller, etc., etc. So when I do that, of course, now I don't see anything. I just wait. And now, I'll show you later, but the LLM is actually doing some call to the MCP server, getting some data, figuring out some whatever it needs to figure out to answer the prompt. And we will see the components, if internet is working correctly, that are going to come in the UI to build the UI. And I don't know in advance which component it will use, but it will use some of them. A title, okay, nice. And of course, in the prompt that I'll show you in the code later, we ask it to fetch some product, and this is where we're going to see if we have interactivity, because it's supposed to generate some product where I will add the button add to cart, and we will be able to click on add to cart, and it will add it to the cart, right? So we have a real component that has been streamed, and we have full interactivity on it. So let's scroll a little bit. So, okay, it decided to display this kind of weird. We probably fix this, but it has decided to do this and pick this featured vinyl here. And if I want to add it to my cart, I just add to cart, and you can see the counter here incrementing. You cannot see because there is a picture and picture. If we remove the picture and picture here, you can see that right now when I click on add to cart, it's adding to the cart. So this is just to prove, to show you that the LLM just generated the UI. So if you apply that to the cart, this is quite cool because you can have a cart, you can render half of the cart like you would do today to make it fast, to make it quick, but then you can stream part of the page from the LLM, like recommendation or add-ons or warranty blocks, stuff like that. So this is really cool because it could be hyper personalized. So how does it work? Let's switch to the code first, a little bit. So this is the project. It's big enough. Cool. This is Next.js, so you know about it. So it was a specific page, lab, persona, slug, and the page, right? So it was the low vision reader or the React rocker, and I wanted to build a specific page. So the specific page is actually just a client component, which is going to use the JSON render library, right? You provide an endpoint, and this is where all the magic would happen. This is the endpoint. And the rendering of all the components, it's actually quite simple thanks to the library. It's just this, right? This is block, and actually this is the most important block. You say, where you say to the system, okay, render the component coming from the server using this registry. And I'll show you what is the registry. It's basically the design system that you describe for the LLM. We're going to check that right now. So let's have a look at this catalog. So the JSON render library requires you to feed the catalog the same way if you have built an MCP server. Usually you create your tools and then you have to describe the tool. What is the input? What is the output? This is the same here. I have all my components, the props of my component, when to use the component, and an example of data for this component. So you create this big library called catalog, and then the JSON render is going to do the magic in the front end. On the side of that, this is description only. You need to be able to render your component, right? So you have also requirement to create the registry, which is how to render those components. And this is where you can bring all the magic of your project, all the good stuff that Aurora mentioned before, use optimistic, use Scharff, context. Here, this is React, business as usual. You just say, okay, when you LLM, you pick a component, this is how you should render it, right? So this is a bridge between the description and the runtime. Once you have that, as I said before, you just have to use this renderer block, and the magic will happen. Nice. What is interesting to look at now is how do we generate this component, right? How do they look like, and how do we generate them? So I showed you before on the website, but the output of the LLM is something like that, right? So it's a bunch of weird JSON line that are actually describing every single component. The path is a tree component, because as you know, components are trees, and then the props, stuff like that. So this is, instead of returning text, the LLM is returning this kind of blocks. Cool. How do we do that? Server side, right? So I showed you before, we actually call the client component. The client component is using a hook, which is called use UI stream, provided by the JSON render library. And this is what you need to do, right? So API generate and a page. So let's go check that. So API generate. So we can look at this. Oh, this is exactly the same. To generate recommendation in the cart only. Let's have a look at this one. So I have a bunch of caching mechanism to make it fast, because once you have generated one page, you don't want to regenerate that page again. So we're going to skip this. What is really interesting is this block. As you have probably done that before when you are working with agents, same as what Nico showed before, you need a user prompt and you need a system prompt, right? The system prompt is, you are an helpful assistant. Please answer my client with this, this, and this, and this. Here's the system prompt. I'm going to show it to you, but it's, you are a rendering agent. Pick the correct component to display this or that. And this is the user context, which is the persona and the page. In the cart, you provide the cart, right, as context. So this is just building the user prompt. And what is cool to look at, it's the agent itself. So the agent is going to use the Vercel AI SDK, which is giving you this little guy here, tool loop agent. And this tool loop agent class is going to manage the agentic loop. Again, Nico showed a little bit of that before, right? On the browser, here it's running on the server. But basically, you give it the model. So this is an example. I'm using Anthropic here. I provide my key. This is the this is connection with Anthropic. Then I've decided to use Sonnet here to make it fast, faster than Opus. And then I just need to give it the system prompt and also the access to some tools. Here, as I said before, I just want my agent to be able to fetch data in my real catalog and crystallize it here. So I just created the crystallized MCP tool, which is once again very simple, right? You give the transport, the URL of the MCP tool, and the Vercel AI SDK handle the rest, right? So it's like 10 lines of code, and I have a fully autonomous agent that can answer my question, fetch the data. Here you can add as many tools as you want, right? So you could have get weather, I don't know, go check the top chart list of hard rock music, so you can order the recommendation, etc., etc. Of course, you have some simplicity also to manage this agentic loop, because it's very important to understand that here it looks like it is only one call, but behind the scene, as again Nico said, it's a loop, right? So we send a message to the LLM, it answers, oh, I don't know what product you have. Please use this tool from the MCP server to get the data. Then you get the result, you pass all those messages back to the LLM, and you get a final response at some point. And here, the system prompt is explaining to the LLM, please, when you return the final response, use this structure, use this JSON syntax, and use this set of components that I define to you. And this is actually coming from the library. The system prompt is catalog.prompt, and they have, wrapped everything into it. So this is basically how it's working. If I go back to the project, everything has been generated. Again, we have data binding, structure, and validation. This is quite interesting. So you can have the cart, you can build some blocks, you can stream some blocks. But we could go the next step and let the LLM build the cart page completely, right, based on the content of the cart. So this is what I built here. If I go to this cart, I can say smart cart. And here we will have a cart that has been completely generated by the LLM. Not yet, not completely. And this is also to show you that you can give some context at first. And the LLM was able to very quickly answer by the current content of the cart with still data binding and everything. And then it's generating the recommendation. So it's cool. We are in e-commerce. I'm going to come back on the key takeaways after that. But yeah, this is streaming components into your project. So if I go back very quickly to the slide, what did we just do, right? So we have a Next.js project. We can stream components. Awesome. We get some JSON. We are able to convert this JSON thanks to library into component. We have data binding, etc. Nice. We have access to any kind of MCP. You can also build your own tool to make it completely dynamic, to make it agentic. Nice. And yeah, we can split that so we don't have to necessarily generate a full page, but we can just inject some component wherever. We need some caching to make it fast. So basically, right, the LLM is streaming you some data. You can save this stream into a cache of your choice, and which means that when I reload the page, we are just fetching the cache, and it's faster. But for a cart situation, the cart is changing all the time, so you are gonna miss the cache, right? So let's flip it a little bit and see if we can, instead of rendering a component inside the web shop, we cannot render a component in the AI, in Claude Code, right? So how this would work is the web shop itself could expose an MCP server, right? The web shop can be an MCP server, right? At the end of the day, MCP is just a server, right? It's just an HTTP server. So here is how it would work. So I have my Claude Code. I mean, it's not Claude Code, it's Claude. I have the MCP server instead, and I said, okay, I am live on React Norway, and I would like you to show me the hard rock vinyl that you have in the shop. And now, if it's working, the MCP client here will know, oh, I have a tool, but this tool doesn't return text. It will return a UI. And this is a UI that I built in my shop. Right? So we are bringing the React component inside Claude Code, and not just Claude Code, into any MCP client that you have, right? So it will work with VS Code. You install this MCP server of the web shop in VS Code, and that would work the same way. And here you have full interactivity as well. You can create buttons, add to cart. Here I made it very simple, but yeah, this is you. You control the UI, and it's not static. It's React component, and I can prove that. To create an MCP server on top of Next.js, there is a solution for that. So here it's API, MCP, route, same as usual. And here you just have to import the MCP handler, which I think it's Vercel again. We did that. And you just register the tool like you would do. Those tools are different than maybe the tool that you have already built, because they respect this new specification that is coming. Maybe if you have heard about that, it's called MCP UI or MCP apps, which is a layer on top of MCP to not only return tool result as text, but tool results as UI, MCP UI. And so if I go back to the code, you can see that I've registered those tools, and those tools are actually just React. So I can show you the one product overview. You have an entry point, you mount the app, you attach the CSS, and here the app is business as usual. You can use the component that you have, and then the app will be rendered inside your MCP client. All right? Go back to the slide. So, is that ready yet? At the end of this journey, we've proved that it's possible, right? You can stream React component with full interactivity. Nice. You can bring those components to your MCP client, VS Code or Cloud or whatever. But is it usable? I will say that the later is usable, right? Inside Cloud Code, it was really fast to render the component, but on the website, it was not fast enough. It's not because it's possible that you should use that in production. we care about performance when we are in commerce, and you want that to be fast. You cannot wait for 4 seconds to render the cart, right? So I don't think it is um, it is really ready yet for the cart, but for building a project or building static pages like we do with Next.js, it's quite amazing, right? You can just describe the prompt, it's going to build the page thanks to the MCP server. So that's nice. Also, I can hear maybe in your head some of you saying, well, wait a minute, why do I need a UI in the next futuristic agentic way of shopping? Because my personal assistant doesn't need to have a UI, right? It's not going to, it doesn't have any eyes, right? And that's probably right. It's probably right. We don't know what it's going to be in the future, right? My pick is, I think it's true for commodity buying, right? You need milk, you need to buy some batteries, the stuff that you don't care too much. Your personalized assistant is going to do that agent to agent. Nice. But you still need some kind of experience with brand. You need to be in love with the brand when you buy something that you love, right? Why do you buy Adidas or this brand? Why do you buy a Porsche versus something else, right? I don't have a Porsche, but if I wanted to buy a Porsche, I would go on the website to feel the brand, right? To understand the experience. And this is UI. And this experience must be personalized to myself. Um, so I think this is going to be useful in order to generate hyper-personalized UI. So commerce is about to change anyway. So whether you use augmented commerce, UI inside the assistant, or no UI at all, this is on you. I don't have the answer. But if you have another question on the way I've done this journey, you can ask me now.
Very well. We maybe have time for 1 or 2 questions. Anyone? Dinner time. Thank you.
Nice. Thanks.
Okay, thank you for coming. I'll see you upstairs. Go up the stairs now. Concerts will start at 7. So I'll see you around. Thank you.